This is all very strange, by the way. This is all very, very strange. Wendy is setting up some kind of official fan club for me. I don't know where or how you're setting up, Wendy. Um, but but yes, that's great. I should let everyone know what I'm doing in the meantime. So I got one of these finally, um, and of course the first game I picked up was Animal Crossing. So at the moment I'm giving Blathers uh, animals, and it's the best when you give him an insect and he doesn't like it. Anyway, let me let me quit out of that because we actually have stuff to do. Okay, how is everyone? This is the not nearly as formal as the previous lectures live stream, which is what are we now? 3 days out from the exam. And this is a stream just to kind of supplement for everyone the the content that we've had so far in Comp1511 and to give you a chance if you want to ask me to do some final demos and things. So I'm around for a couple of hours and available to just run through any of the topics that people have been having trouble with or anything like that. Oh, looks like Tom and Dean are both there. So that's handy. If you two are here, then I don't really have to do any work. So yeah. Um, I don't have any content that I've prepared for this stream. I was not planning on it being me delivering things to you, but rather um, me answering your requests in a sense. So if anyone has anything they'd like to know about, anything that they're studying and it's just not clicking, and you want a clarification or anything like that, um, then I'm more than happy to go through some demos. As you can see, I don't have my normal slide deck or anything going today. I'm just logged into VLab instead. So, I'm open to any questions at all that anyone has to ask. Um, Hit me up in chat. Oh yeah, Donna was here from earlier as well. Um, so, okay, the first question there is from Dicko. You are guessing the questions get progressively harder in the exam, like easy stuff first, then stuff that's basically impossible. Exactly. Um, the first questions, the very, very first questions in the exam, I've already written them and they're ready to go. We've actually got the exam up and running already, but we're going to run a couple of tutors through it to see if they can pick up any of the mistakes that we've written in. As we all know, we're all humans, we all make mistakes. So we have no, we're not under no misconception the exam is perfect and ready to go the second that we write it. So I write a lot of the conceptual stuff, and Tom does all the nitty gritty to make sure it actually runs in the exam environment. Um, so we do need to kind of make sure everything's going to work. But yeah, the first few questions in the exam are so easy that you could potentially not know anything about Comp 1511 and have enough time in the 24-hour period to watch the first couple of lectures, basically type the code in and run it and see how it runs, and then get a few marks. So I would say that people who had not done Comp 1511, so literally not done the subject, could still get maybe about 5% out of 100 in this exam. Um, that's not going to help if you're trying to pass the course, but that's the level of the ease of difficulty. The very first multiple choice short answer questions are a bit like that. Even the first, I'd say the first two um, exam questions out of the 7. So there's the 10 multiple choice, which are the easy ones, and then the 7 ones, which are practical, where you actually have to write code and submit code the same way you were doing in your labs and things. You could potentially know nothing about the course and just watch the lectures, it would take you several hours. You know, you'd want to watch the lectures and maybe do some labs and stuff, but you'd have a decent chance of completing questions 1 and 2 with no experience in the course and just reading it. So if anyone there is thinking, oh my god, I am so screwed, I have not learned anything, there's still a chance that you can meet those minimum hurdles. The minimum hurdles are not in any way designed as a punish. They're not in any way designed as something that's going to cut someone out who's put a genuine effort into the course. They're actually there for anyone who's basically cheated and copied the entire course. When they hit the exam, they're like, oh, I don't even know the basics. That's kind of actually what the hurdles are for. Okay, let's see what other questions there were. But yes, Dicko, you are right in thinking that. Michael is asking me, can I do night moves? You want me to do night moves here and now? I'm not sure that's that useful for everyone about the exam. I will put that question in a list of possible questions that I could answer today, and I will answer it. I could probably answer it in a diagram, but I will only answer it if all of these kind of more pressing questions have already been answered. Because I think that night moves is really interesting, and once you've gotten into your second year of computer science, you'll do it in like 20 minutes. Because you'll have done stuff that's so much harder, you can sort of backtrack, specific keyword, to that algorithm, and you can actually do it. But I'm not necessarily going to do it now. But we'll see. Tom's suggesting the possibility of argc and argv. Yeah, I can potentially talk about that. Lydia's asking, why did the assignment talk about freeing arrays? Do they have to be freed like nodes? Did we say anything about freeing arrays? Tom says we put mistakes in there intentionally for them to find. Curious Cat was asking, would night moves be easy to a second or third year comp student? I think so. Having said that, it's been nearly 20 years since I was a second or third year comp sci student, so I can't remember the difference between what I knew in second and third year and what I knew after, you know, a couple of years being a professional software engineer. So hard for me to say, but I think it's not that hard. This would be actually a really funny way to test your tutors. So you can ask different tutors whether they would know how to do it easily, and the tutors who are newer, so the tutors who are maybe, I think there's a couple who are actually even still in their first year, but most of the tutors are in second year. The ones that are just in second year would be like, oh, I'm not sure. And the ones that are in third or fourth year would be like, yeah, piece of cake. So maybe you'll get that kind of answer. Curious Cat says something they can do in 15 minutes. I would not say anyone would be confident in saying they could do it in 15 minutes. I think the time it takes to set something up, write the code, and test it is longer than 15 minutes, even for very trivial things. Let alone something like night moves. I'd say if someone had built up a whole bunch of libraries and stuff that they were using for stuff like this, like I've got some, not in C, in C++, that I would use for what we call node graphs or game trees. I've got stuff like that, so I think maybe I could get it going in that amount of time, but I'm not fast. I'm much more thorough than I am fast as a coder, but there's some really fast coders that maybe could do it. Tom saying we put mistakes in there intentionally for people to find. Mark and I don't make accidental mistakes. So I'm assuming that means that we put arrays, so we mentioned arrays in the assignment by accident when we meant linked lists. So that was to Lydia's question there. Dean saying, yeah, we're always testing you. Okay. Scrolling down chat. Having a look at the prac exam is something that we could potentially do. Now that it's over? It's due sometime today, yeah. Peter is asking, is the course a double pass or is it just hurdle questions? I'm not sure exactly what you mean by double pass, but I think you mean that there's more than one pass requirement. You have to pass the hurdles and get more than 50% in the course. This course is not scaled. either. It's like 100% raw, so you can count your marks. And so, for example, assignment 1 was out of 15. That's a percentage of the course. Assignment 2, oh, we haven't released assignment 2 marks because we haven't had time to mark them yet. But you can add up all of your lab marks, all of your weekly test marks, and your assignment 1 marks, and that's exactly the percentage of the course that you've completed. So some of you already know, especially if you're reasonably confident about assignment 2, you already know that you've passed the course, and so the only thing that you have to get over is the hurdles. I think if anyone's passed the course by doing assignment 1 and assignment 2, the hurdle questions will be easy. You've seen several examples of the hurdle questions now, because the weekly test has examples of rough idea of the examples of questions 1 and 2. The practice exam, the partial practice exam that was in the labs, also has examples of questions 1 and 2. So hopefully that gives you enough information to know that you're pretty confident that you could pass those questions. I mean, you can see how we've set them up. They're not that different from the very first stages of the assignment. So should be okay if you've completed those and you have them on hand. When you're doing the exam, you can say, okay, I did this kind of technique before, let me look over it and I'll do it again for the exam question. Michael's saying, I feel like I'm not going to finish the last question. Should I still attempt it for partial marks or not bother? Well, there are partial marks on offer. If you think you can't finish it, but you think you can start it, if you think you can show some decent ideas in question 7 in the exam, then go for it. Partial marks are on offer. If you're really tired and you've passed the course and you manage to complete like all the other questions in the exam, you can walk away. Like, I've got plenty of people who walked away from that final question and said, look, I'm not even going to bother. There's a lot of work there. It looks like something that I'll probably be more comfortable with later. I don't need to go through that level of punishment. So you can do that as well. I've seen people do that, and I've hired some of them as well. So there's no real pressure to have to complete it. I've also hired plenty of people. I mean, not that whether I hire someone as a tutor is a question about whether someone's good at computer science or not. I hire people as tutors because I think that they're going to be able to create an environment where people are happy to learn, which is a completely different skill from being good at computer science. So I should say any people get HDs without even attempting that final question, because it's more than possible. Mingji's asking if I can demo padding left. I'm not sure how to deal with the character related data. Yeah, we could potentially do that. Lydia, how does the marking work for the exam? The questions in the exam have very, very specific number of marks. So they will be marked very, very similarly to things like lab exercises and weekly tests. Weekly tests are a bit different. Weekly tests are really, really friendly in that you can fail the weekly test and still get half the marks. It's not really going to be like that in the exam. The exam's going to be marked much more specifically and a bit harsher in a sense. So the multiple choice questions, you're just right or wrong. You're going to have put the right input in or the wrong input in, and it's just really matching it character for character. If they're multiple choice exactly, then it just is the letters. If they're short answer questions, we're still going to be checking that the format is correct. You don't have to worry about things like new lines and stuff on the end. We just want the actual data characters. The practical questions, the 7 questions, they're all going to be marked a little bit like lab exercises in that we will do an automated testing thing. If you pass all the automated tests, then you get full marks for the question. The automated tests are obviously going to be more strict, and we're going to be checking really, really specific things as opposed to the auto tests. The auto tests are there to give you an idea of how well your program's working against certain circumstances. But if you're sure of something, you should be sure of it based on the specification, not based on the number of auto tests that passed. So you can say, I'm meeting the specification, I'm confident of that. And if you're at that point, we can be like, yeah, sweet. And then you'll pass the auto marking. If you don't pass the auto marking, we mark it by hand. So, for example, if someone really knew what they were doing, They wrote really good code, they tested it, and between the final test and the submission, they went, oh, I just want to fix up this thing, and they accidentally delete a semicolon or something like that, then they're still going to get some marks. They're not going to get full marks because handing in something that you've edited and not tested is not a good idea, and we can't give you full marks for that. But we can still see that someone had the right intentions and had largely complete code. You're probably still going to pass that question. You're not going to get much more than that though, because we're expecting completeness out of you in an exam. So you know how the assignments, we've had times where someone's made a small mistake, and that small mistake, maybe in the way they print their output, has made them fail all of the auto tests, and then we'll go back and we'll recheck everything in those circumstances. We're going to do the same kind of thing in the exam. So if someone doesn't get full marks, but we have a quick look at their code and it says that they could potentially have gotten decent marks out of this, you'll get a lower percentage of those marks. You're obviously always going to get docked some marks for handing in something that doesn't compile or something like that. There's the we can't really have that, because if we were in a professional environment and we're writing programs for the world to use, we don't like the first release of something to not function. Like, we're okay if the first release for something is rushed and it has some bugs, so it doesn't meet all of the requirements, but that's still not great. So that's never going to get full marks, that kind of thing. But if something is on release day not compiling, then we've got a more serious problem. It's very hard for that to happen, but it is possible. Okay, who was I answering there? I can't remember. I think it was Lydia's distribution of marks and stuff like that. Yeah. Also, you may notice we've put some information out there already in the final lecture. No, the one before the final lecture, which was the exam, showing that the 10 multiple choice questions give you 10 marks. Questions 1 through to 4 are worth 15 marks each, and questions 5, 6, and 7 are worth 10 marks each. So the bulk of the marks is in the first 4 practical questions. In fact, you could answer nothing except for the first 4 practical questions and still pass the exam. So we consider that to be core fundamentals. Stuff people really need to know is in there. And then the icing on the cake is whether you can do the super hard stuff in questions 5, 6, and 7, and the sort of what I would consider the freebie marks, which is the stuff that most people should try to remember from the course, is in the multiple choice and short answer questions. So that's the kind of rationale behind the marks distribution. So I think Edison's got a question there about how many marks are each question worth, and I think I've just answered that question there. Shrey says Knight's Move is still hard. So if I remember, Shrey is a second year student at the moment. Dean says Knight's Move was his final exam question in 1511. Dean is a about to graduate 4th year student. What's your take on on the difficulty of Knight's Moves, or how long it might take you to do that now? Oh, Tom's already given the marks distribution. I should keep up with chat. Dean said you tried it for like 10 minutes and gave up. 10 minutes is not enough time. You can spend more than that. Oh, sorry. My Slack notification sounds are coming up. I'll just kill my own sound because I don't need the sound. But Tom is sending me Slack messages just to remind me of things I need to say, or especially things like don't tell them the answer to this. The due date hasn't come yet. Yeah. And Wei is saying maybe question 6 is the possible one you can try. So questions 5 and 6 are like the challenges in the labs. So they're like reasonably hard things that are interesting and may take like an hour or two if you're like an average COMP1511 student. Actually, an average COMP1511 student's not even going to complete both of those. I think, thinking about the number of marks that people get on average, but can have a crack at them, and they may take a while. Peter's asking if you have to pass the exam. You don't have to pass the exam, you only have to beat the hurdles. So in terms of like some subjects that you have to pass every component of the course, we don't have that. If your marks add up, then you've shown competency across a wide range of different things and it's fine. What was I going to say? You have to meet the hurdles, but passing both hurdle questions is only like about 20 to 30 marks out of the exam. You're probably, if you can pass the hurdles, you're probably going to end up with a mark in the exam of around 40 anyway. So it's not too bad. You're going to get pretty close to passing the exam if you pass the hurdles. And everyone's telling me to mute my notification sounds, which I've done now. That was 10 minutes ago. That's how far behind I am in the chat. And Tom's already answered these questions. I should just jump to what's happening in the chat right now. Taylor's asking, if you think you can figure out the logic of the harder questions but can't implement it, can you just write a paragraph of comments explaining your brain? You can, but we're not going to mark them. So it's not something that we're going to get marks on. So we're not giving marks on the theoretical. However, if you can write those comments and they say, okay, here's my plan for implementing a solution, and then you can say, this function implements this part of the plan, this other function implements this other part of the plan, and the whole thing doesn't even run, but those functions exist that implement parts of the plan, you're probably going to get some marks. So you can, if you show your problem solving ability, your ability to break down a problem into parts and then solve some of those parts as sub solutions to a bigger problem, you'll definitely get marks for that. Well, so long as you're on the right track. If we see that you're not actually solving the problem with those bits of code, then you won't. But we have criteria that says, to solve this problem, you need these parts. And if you implement some of those parts, even if they're not even connected up and don't work, we're going to see it and say, hey, that person looks like that could have worked. Then we can give some marks in the final questions like that. Oh, Wendy's got a huge question. What would you say are the pros and cons of working in tech? Is that a question of like, as someone working in the tech industry, what I like and don't like about it, or what are the things that we should be doing in the tech industry? I think it's probably like what's nice or not nice about working in tech. I think at the moment, let's put that one for later, because I'm already 10 minutes behind in the chat. But we'll talk about that if we get time afterwards. But I think, short answer, Wendy, to your question, is that working in tech is very comfortable because tech makes a lot of money and so it hires a lot of people. So it's reasonably easy to get a job and keep it. And it's easy to jump between jobs and other jobs. When I say easy, I'm not saying it's like objectively easy. I'm saying that the market has a lot of jobs, and it's very, very different from, I could be having a very different conversation with you if we were talking about, let's look at one of the adjoining industries, like the film, the VFX industry for film, which obviously hires a lot of programmers to do computer graphics stuff. I would say this is super cutthroat. It's really hard to get into. You have to get your foot in the door with low-paying jobs where you basically press the button on the server to turn it back on again when rendering's happening overnight, and then hope you can get into a position where you're coding again. Now, I would never say that to a comp sci graduate, because comp sci graduates can get more work. There's more work around, and depending on what kind of jobs you want, there's so many places that will hire people. I mean, you can tell that that comp sci is a place where good graduates are in demand because of the internship program. Other industries don't have the same level and depth of internship programs that comp sci does. So computer science and software engineering interns are a way for a company to relatively risk-free, or at least very low cost, test out a large bunch of graduates before they graduate, and then hopefully secure some of them before they graduate if they've shown that they can do well. So these companies are doing this because it works really well for them, but also if they wait until people graduate to hire people, then they've lost a race against someone else who's potentially like tapped someone on the shoulder and said, you did really well in this internship, we have a job lined up for you. And I know that there are some students in CSE, and this doesn't have to be everyone, but I know that there are some students in CSE who have a job offer that basically says, when you graduate, here's the job waiting for you. And they'll get them like, I think the most extreme example I saw was someone who got a job offer that basically had a start date more than 12 months from when the offer was given. So they were they were offered a job after an internship when they were in their, like, I think midway through their third year, and then they're doing a thesis now. So they've got a whole nother year to go. And and so that kind of thing is their way of saying we need the best, because it's competitive trying to get the best. So it's really nice in that kind of industry. So I used to teach the computer games industry, and so I would definitely teach people who I'd say, you're an amazing programmer, you work really well with people, you're like a perfect employee. If I had the money and a company, I would snap you up immediately. And then I get an email from them 6 months later saying, well, I still haven't got a job. And that kind of thing makes no sense to me, and I think that means there's a scarcity. So that's why the general computing industry is really good, because there's not that much of a scarcity of jobs, so it's not that hard to get one. Anyway, I should go, because I said I wasn't going to talk too much about that. But yeah, I guess the cons of working with tech is that we tend to work a lot. So again, similar thing. Not enough people for the work, which means the company gets work that it has to do, and there aren't enough of us in the company to do all the work. So in those situations, you may find yourself working longer hours than you expected, and it's your decision on the level of commitment that you throw in. So if you join a startup, then you are committing yourself to being part of the company, which is different from working for a company. Sometimes when you work for a company, you take your pay, you do the work they ask you to do. When you consider yourself to be part of the company, you have shares in the company, equity, that kind of thing, you might work a lot harder because you know that the company's success is directly tied to your financial future, in a sense. Anyway, I should move on. Wei is asking, is question 6 harder than the weekly test final question? Some of them. The weekly tests, as you can see, they ramp up slowly through the course of the term. But if we look at the final weekly test, I can't remember what the question is. I can't discuss it because it's not due yet. But I think the final weekly test was somewhere around a question... What was it, Tom? Was it a question 4? Or something like that? So I think we haven't really shown the question 6s. But some of the weekly test final questions would be around the question 5 and 6. I'm trying to think of any of them that I can remember that I wrote recently that would be around that level. If you didn't know anything about linked lists, then the Game of Chairs one is somewhere around a question 5 or 6. Did I do Game of Chairs as a lab exercise or a weekly test? I can't remember which. Yeah. Tajwa was asking a +1 for Wendy's question about the working in tech. So I think I've said something about it. I don't know how deep you'd want me to go objectively, because working in tech means you don't have to do physical labor. You tend to be around people who are, I guess, similar in a certain way to how you're going to work, just because most tech companies are going to be largely staffed by people. I'm really ballparking this, but I think people under the age of 40. You're going to definitely get people over the age of 40. That's necessary. But there's going to be people who maybe, I don't know for certain, but maybe understand a similar way of living than you, similar demographic. But I can't say that because you're all very different demographics, so there's no way I can guarantee that. Anyway, I should move on. I said I was going to move on from that question. Oh, Wendy's asking. We talked about soft skills. What, in terms of what's required to succeed in industry, what differentiates good versus great comp sci professionals in terms of hard skill? In terms of hard skill, nothing. Because there's nothing to say that you need hard skills to be successful in the as a computer science professional, because some computer science professionals are very successful entirely based on their soft skills. Exhibit A. I don't know if I count as highly successful. Mildly successful. Has a full-time job. That's all I've got. I've just got a full-time job. It's no big deal. But as you can see, I have my success in computing has nothing to do with my technical skills, because when it comes down to it, the amount of technical capability I'm showing at the moment in this is at the level of, say, a third-year student. It's not even an honors graduate like I am. I don't use most of the stuff that I've used in the past or I've learnt. All I do is at the technical level, it's a very low level, but a very, very high level in terms of communication skills. So I've learnt more about communicating than I have about writing code. And there's plenty of positions out there that do the same kind of thing. And there's people that work on design of things rather than... actually, design's not a soft skill. I forget. So there's different kinds of hard skills. There are definitely people out there whose entire career is based on their hard skills. So you get people who, everyone gets, some people get shifted into management roles and some people don't. The people that never want to go into management roles, you'll see people turning down promotions and stuff like that. Well, they're not promotions. Getting made into management is not a promotion. It's a sidestep. But people who refuse to manage other people because what they are is a gigantic brain on a set of legs, right? Oh, and hands to type in. And those people are there to develop really significant algorithms and stuff like that. And we always need some of them around. So some people are going to build their skills, their professional career based on hard skills, but other people are going to build it based on something else. So I would never say that there's the difference between good and great is a matter of hard skills. But if you wanted to, I would say that the difference between good versus great in terms of technical capability in a software engineer is, can you interpret what's happening in can you interpret what's happening in the world around you? Where's research going at the moment? Can you keep up with that? And can you re-implement the research that other people are doing by only reading their papers? That's super hard to do. So you can read an overly dense research paper and go, oh yeah, I know how to implement that. That would be one of the most solid hard skills where there's there's two people in a company that can do that. Depending on the size of the company, but it's a small number of people in a company that are that clued into that kind of thing. And usually what we do is we just put them in a nice cozy office and get them to do that kind of thing, and then teach the rest of us how to use it rather than necessarily having them talk to clients all the time, or having them go with the marketing team to present things to the world and stuff like that. That's much more the kind of thing that I used. I got co-opted by marketing a lot of the time, and as you can tell, because I've ended up making a career out of public speaking, so obviously my skills were in a different area. Having said that, I did try the research things, just wasn't very good at it. Anyway. Okay, so questions about question 6 in the exam. People are asking about the level of difficulty. Question 6. Tom went in the background and picked out a few things. Going electric is a question 6. So going electric was, I can't remember which lab that was in, but it was early. I think it was week 5-ish. You can always search for it if you want. The week 9 weekly test, which was remove ordered. Yeah, Tom's confirming he's pretty sure it's lab 5 that going electric was. So that was an array question 6-ish. The week 9 weekly test, third question in that one, which was remove until ordered, is potentially a question 6 as well. So if you want to look at some of those specifics. Tom's answering a lot of questions there, which is good. Lydia Teal's asking, can you explain the string contains function in testrealm.c? The part where you put a exclamation mark in front of return, blah, 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 not equals null, and if not string contains, what does the exclamation mark do? Okay, Shrey is answering that already. Right, okay. 1 second. At least we're doing a little bit of... Oh yeah, this is the folder that I'm not going to open. I knew that people would see that go, oh wait, it's there. No, I'm not opening that one today. But I will open Castle Defense. And we were looking at testrealm.c. So this is the Steerster, which is a standard library function that will give you a substring. So if we have a string of characters and then we have a string inside it, like a partial string inside it, that's what we would call a substring. And so this will give you a pointer to a substring, as in what it's going to do is it's going to aim you somewhere into partially into a string. However, it can also give you a null. So if it returns a null, like here, if this thing is not equal to null, I'm not sure if this is exactly the bit that you're asking about. Yeah, I think it is. And I think Tom and Shrey have already kind of explained that. Oh, I am so far behind the chat right now. I may have to skip over the chat everywhere where I see blue text of other people answering, because I think this question's already been answered. Wait, I don't even know where I am in the chat anymore. Wait, no, I went too far back. Sorry. You can't see me scrolling madly through this chat and trying to find stuff. Tom's talking to people about the hurdles. Oh, Tom's saying he's been DMing me with stuff to talk about because he knows that I can't keep up with the chat. Because if I stop to talk about something, chat just flows. He said going electric is in lab 4. So going electric is a good one to look at for a question 6. I think it might actually be a question 5. Going electric, because question 5 is going to have more array stuff, and question 6 is potentially going to have more linked list stuff. They get hazier at that point. We don't force, like questions 1 and 3 are definitely arrays, and questions 2 and 4 are definitely linked lists. Question 5 and 6 vaguely follow that trend, but you might have to use both in some of those questions. Okay, I'm going to assume people are answering a lot of the stuff in chat. Okay, so if this thing can return a null or a pointer to a substring, we're checking whether it was null or not. So what we're saying is, here, we're returning the result of this not equals. So if this thing returns a pointer that isn't null, then we're returning true, because we're saying it's not equal null, so we're returning a 1. If it gives us a null, we're returning a 0. So this thing is just saying, is one string inside another? And then this is like stacking a few operations on top of each other. So first of all, we do the function, and that would give us a pointer or a null. And then we're checking if it's null or not. And then the result is the result of this not equals, and that's the thing that's returned. So that's where it's returning just an integer, even though it's this long, complicated thing. I think that's already been answered by everyone. Taylor's asking if the first 10 questions are all multiple choice or some short answer. It's a combination of the two. So it's either one little line of text or an A, B, C, or D. Some of them are specifically A, B, C, or D. Some of them say that some might be correct or not. It's a real hodgepodge kind of thing, because it's me basically saying, these are the things I want to ask people about, partially because these are the things I think people need to know, or these are things I think I want to remind people of that might be useful. So I don't want to have the exam miss any parts of the course, but some parts of the course are not super important. Some parts of the course are more important later in your career, and you'll learn about it again later. And some parts of it are so easy that I just want to tick off that you can do them. So one of the things that I most want to tick off that you can do is you can actually work a compiler and run a program. So can you run DCC and can you run a program? So there's questions on that even, and they're super easy, right? Right, okay, I'm so far behind chat. Dean said Knights moves is easy, really easy now, and he thinks 10-15 minutes. Chat delay check from Edison, 2:18 p.m. So I'm now 20 minutes behind. Okay, I'm gonna scan through faster. And Tom's saying question 7 just becomes annoying when you're an older student. So not necessarily older, but just have done more stuff when you've learned more. Shrey's saying, Tom, you should live stream during the exam. I had actually thought of live streaming during the exam and just having somewhere where people could just hang out and say, I'm taking a break from the exam. I want to watch Mark play Animal Crossing, which is possible. I need to set up a capture thing so I can capture the HDMI output from my new Switch so that I can stream it. Although I think that would be pretty funny if I just transitioned from being a computer science lecturer to just being a streamer. I think that would be pretty funny, but I'm not going to do that. There's no way streaming would ever pay a stable salary, so I don't think I want to do that. Oh, Tom says you can still hear my Slack. I thought I'd muted that. Okay, I'm muted in OBS now. So I muted what's coming out of my speakers, but I hadn't muted OBS. Tom's also telling me that everything in chat has basically been answered. So I'm going to skip Leon's question about getting above 50% 1511 and failing a hurdle, because that's nearly unheard of, I would say. Talking about live streaming during the exam, we had a live call. We had like a Google Meet going for everyone who was supervising the exam. And yeah, and so that was always like, oh, the students have discovered this issue with the exam. Oh, now we have 200 emails that all have that same issue. So we'll find that happening. That will happen on Friday morning. We'll be all hands on deck like that. Ooh, someone's talking about different societies. Other than CSESOC, obviously. Because I think everyone's going to have some connection with CSESOC here. Women in Tech is really cool as well. They're good people. EngSoc I don't know much about, but Dean used to run parts of EngSoc. I knew you were on the exec at some point. Yeah, lots of hobbies. I would think about joining a society, at least one, that has nothing to do with your professional path. And I think that is actually something that's quite important to do something that's outside of your chosen professional path, because you need something else happening in your life. Like, it's not 100% necessary, but I find that having hobbies that have nothing to do with computing allows me to switch my mind off and think about other things. It allows me to let my brain relax and do something else. So heaps of people are going to do sports, which are really cool, because physical activity is also very good for your long-term health. Very good for your current brain as well to have physical activity. So those things are good. But just anything that allows you to get your mind out of how you're studying, because that gives you a release that makes you better at studying when you go back to it afterwards. Oh, Wendy's saying that at some point you did want to work in game design. There is still work. It's just hard to get. There's lots of people trying to do it at the same time. Um, it's like I don't know if anyone knows about how things like, say, the fashion industry works. Is that the music industry as well? Anything that is something that's fun to do, that people tend to do as hobbies, um, for the enjoyment. See, no one does like accounting as a hobby. Like no one does that for fun. But people definitely do like graphic design for fun, art, music, creative pursuits for fun. It's really, really hard to take them on as professions because your competition is kind of everyone. And there's so many people wanting in that companies can just pick and choose the best and not even pay them that much. And they're still going to get away with it because there's no other work. Um, so that's one of the difficulties. That's why I have done a lot of stuff with game design and computer games and stuff like that, and have only very rarely made money in the field or had any kind of stable work in that field. So it's rough. I mean, it's possible. Some people do it. I've got friends full time doing that, and they have pinged me about joining their company every now and then, but I'm unsure about that. Yeah. Okay. I'm catching up now. Blah, blah, blah. Oh, you're welcome. Wendy's thanking me for answering the questions. I'm pretty sure. I think Wendy is the first chicken. Although I'm sure that there were people before. Uh, but I think Wendy is setting up some kind of K-pop style fan base. Um, okay. Tom's saying everything in chat has pretty much been answered. Um, all right, I've scrolled down to the bottom of the chat. I apologize if I skipped over chat. So I want to return us to the main purpose of why we're here is to give people help with technical questions and things like that. So let's see what Lydia Teal is asking you about ArgC and ArgV, and Tom said he would push me to do that. Good. Okay, we'll do something like that. Um, there's a lot of chat there I missed. I apologize. Oh my god, Wendy and Taj want me to play LOL. Is this a bad time to say that I was a Dota person, not a LOL person? Does that put a divide between us that we will constantly be at war with each other? I'm not sure. I mean, I got a couple of friends that work at Riot, so it's like I probably should play a bit of LOL, but it's pretty funny. A friend of mine who works at Riot, like my good friend who works at Riot, I've got a couple of ex-students who work there as well, but he's their video editor and he doesn't play LOL, so he's like the one person that got through that, who managed to jump through that hoop to get into Riot without playing any of their games. Okay, so we're here in the live stream, and in the live stream directory, and someone was looking for help with argc, argv. So let's actually do a really simple args demo. Yeah, Clarissa was lolsoc exec at some point, right? Yeah. That would be pretty funny if she was your tutor as well. Shrey just found out I have friends that work at Riot. Tom's like, these are all great questions that Mark should answer later. I played Overwatch as well, yes. Lucio was my main in Overwatch. because he's the easiest to play, and I'm old and slow. Actually, I got really good at Reinhardt for a while as well. I'm all support characters. Does Reinhardt count as support? I mean, he's not like overly offensive. Anyway, let's move on. I said I was going to write some code. Okay, Argsy. So look. Okay, I can see the demand. That people want to talk about other things. This is not the time and place for it, because this is an official COMP1511 stream. However, we will do some other streams. I haven't pinged Dan Mansfield recently, but we'll definitely do another stream sometime soon. I managed to have a chat with Hannah, an ex-student of mine who won the New South Wales Young Woman of the Year, and I want to interview her on stream with everyone, because I think that'd be really cool for you to hear the experience of someone who's a more recent graduate than myself, and like how her path through a career has happened. And we can also talk about random stuff as well. Okay, so Tom is still trying to get me to... Okay. How about that? After 4 p.m. we'll go back to all of these things. And people want to talk about jobs in industry and stuff like that, which I don't know why you'd want to ask me. Maybe I can get some of my friends who are in industry to talk about stuff like that at some point as well. Anyway, so argc and argv demo. So what we're getting here is a main function that, instead of taking in nothing, like the main void, is going to take in some stuff that gets typed in the command line. So this is a very, very specific set of inputs to main. You can only do them in this particular way. If you do them in any other way, it doesn't work. Actually, I've never tried. Never tried just adding other elements in here, but I'm pretty sure they just won't compile. So we have a number, which is the number of arguments. So arguments are inputs. So every program, every function that we've written has had arguments, parameters, inputs. There's like multiple words for the same thing. And so this is saying that the program itself, when you type the words in to run it, has arguments also. And so this will tell us how many of them there are. This is argument count, and this is arguments values. And this is an array of character pointers. So an array, and the type is character pointers, which we can think of as an array of strings. It's really easy to think of it as an array of strings, because then you can think of it as each individual object in the array is a string. Even though the string is made up of multiple characters, we can just think of it as multiple strings. Makes it easier for our human brains if there's no nesting, no depth of this is actually an array of memory addresses, and each of those memory addresses is the start of a separate string. It's easier for us to think of it as an array of strings. So this means that in this program, there's an array of strings called argv. What do I want to say about this? We know that argv is exactly argc long. So argc being an integer, it has exactly this many strings in it. We don't know the length of each string. They're all possibly different. So we don't know whether we know their words, but we don't know how many characters there are there. Tom's saying there are a couple of things. There are some other ways of doing it. Yeah. That's cool. So Tom's giving a running commentary of what I'm saying here, so he's adding a little bit there if necessary, which is kind of handy. Okay, so this is the information we know about what's coming in. So I've written no code here, but just from this, some stuff is going to be created in my main function. So in this program, we will definitely have an array of strings. And there's always going to be something in here, because no matter what, when we've run a program, there's always at least one word. Because the first word is always at least going to be the name of the program that ran. So there's always something in here. argc is never 0. It's impossible for argc to be 0 because a program can't run otherwise. I don't know if that's entirely true. it could be 0 if the program was run via like double clicking an icon on it, I think. I'd have to check on that. And it might even still be 1, it might still be the program name. Okay, so if we have this information, we can then try to use it. So I could say, for example, I could do a printf. So if I'm going to do a printf, I'm going to need to include my input-output library. So let's do a printf. The name of this program is, and I'm going to do this thing where you can print out a string using %s, and that string is going to be the first thing that was typed in. So the first element of this array of strings can be printed out as a string, and that's the first element. And we're not using argc here because we're just assuming that the first element there it exists. Yeah, as Tom's saying there, argv is guaranteed to be at least 1. The standard says it should do that, even though there's a theoretically possible way to make it 0. Okay, so this should be able to say, I can access one of the strings in this list, and I can use it as if it's a string and print this out. So let's save this and compile it. args.c, and the name of the program will be args_demo, I guess. So I'm just going to name it like this. So I've compiled that. Have a look in here, and there is a program called args_demo that I've created. So if I want to run args_demo /args_demo, and I'm not even going to type anything else in here. I know that there's more stuff I can type in the command line. I know that if I type here, all of those words are going to get stored in this array, but for the moment, anything that's going to get stored in that array I'm not using in this particular program, but I'm okay for it to be stored if it wants to. The only thing I'm looking at is the first word, and so let's see what happens when I run this. The name of this program is /args_demo. So it's not perfect, because it still took in the /, but it takes in literally what I type in and puts that into the program. So this said the first word that was typed in on the line that ran the program was this word. So if we want to, we can then say, have a look at everything else. So I can say printf, here are the rest of the words in the command line. So this is the line that was running the command, which is the program. So let's loop. I'm going to give us a little white space there. So if I'm going to loop through the rest of the words, if I've already used 0, I'm going to start at 1. And I'm going to make myself a while loop. And I'm going to loop up until argc, because I know that argc is the length of argv, so I know that argv is exactly argc long. I probably should have just said argc is the length of argv. Yeah, but it's alright. You can kind of tell what I mean by the comment there anyway. So I is less than argc, so less than the count of the arguments. I'm going to loop through. And I'm going to do some printing, so let's do some fputs. Oops, fputs here, and we're going to say let's output a string, and we're going to, if we're using fputs, then we're going to output that string to the standard output. The standard output is basically this window here. So the stuff I type here, the stuff that the program gives me here is standard output. So fputs can do that. So the first argument, I'm doing this off memory, so we'll see if I'm right, but I'm pretty sure I'm doing this off memory, that the first argument is a string. So I know I've got an array of strings here in argv, so I need to pick one of them. And since I'm looping through them, I know that the one I'm going to pick is I. And then where it's going is the standard output. Let's make sure. Yeah. Tom's saying make a video about argc argv. I know that we didn't cover it in great detail. The reason I didn't cover it in great detail is it's something that's quite limited to C, and it's quite limited to running programs on a command line, which is this command line here. And as you know, from a lot of the programs you've used in your life, a great deal of them were run from clicking on icons and things like that, which means argc argv never came into it. You never had an option for typing anything in. So while this is something that's reasonably fundamental to low-level C programming, it's not fundamental to your overall capability as a programmer. Whereas something like the ability to use linked lists is much more fundamental to your overall capability as a programmer, because the idea of nodes and pointers, or nodes and what we call nodes and edges that connect the nodes together, is something that you will see again, and very, very big high-level theoretical computer science stuff is all going to use that. Whereas the command line thing, not as important, but I feel like me holding off on teaching all the details has left a gap in your knowledge that I will probably try to fill better in future years, or just not teach it at all, because it might not be 100% necessary. We'll see. Okay, so fputs here will write out that string, and then we might put a new line after each one of them, and that way what we're going to do is we're going to write out each of the words in the command line, one line each. So I'm going to use more functions here. So I'm getting away from just using printf, because I want to show you some of the other functions as well. So putchar can put an individual character. So if it's a character, it has single quotes, and I can put the new line character there. And so this loop is going to go through, and it's going to write each word. Yeah. And so what we should get there is it'll tell us the name of the program, and then every word that I typed in the command line is going to appear below it. Liang's asking if I can do int value is equal to arg10 without any loops to get the first character of the second argument. That should get you the first character of the second argument. If it's giving you an error, characters and ints usually go back and forth between themselves quite easily. Like, you can usually put a character in an int, but have a look at what error it is, because it might be an error somewhere else. My demo here should now take everything we type in the command line, and it'll say this is the name of the program, and all the rest of the words should be written out afterwards. So let's compile that and make sure that everything's working. So args demo, and the args demo says chicken loves you all very much. And so what we should get here is we should be able to access all of the words that were typed in on the command line when the program was run. Oh, oops. No one in chat said he's behind you. This is the classic thing of me just going quickly and forgetting. It's like, I didn't change your eye. So, I think that's a good point to say that it doesn't matter if you've been coding for, I don't know how long I've been coding for now, 30 years. You can still make really, really simple errors like this. Okay, so let's compile this again now that I've removed the infinite loop that I put in there. Here you go. Name of this program is args demo. Here are the rest of the words in the command line, and it's there. Chicken was the first word I typed in. Loves is the second, etc. So, it's a program that simulates COMP1511. Everyone just says chicken. Yeah. So this is an example of how we can get the arguments typed in the command line, and then grab each one of them as strings and use them. So the other example that we might use is if someone typed in a bunch of numbers in the command line. So say, for example, a bunch of numbers were typed in the command line, and we're supposed to put them in an array or something like that. So if something is a number, we might want to store it as an integer instead. And then we would use something like string to long, stir to all, or there are other functions like a to I that do it as well, that basically take, these are library functions, by the way, not something that we write, can take a string, so it can take one of these and convert it into a number so that we can put it into an integer. I mean, you could do it by hand if you wanted to, by reading each of the characters in the string and then saying, is this a digit or not, and stuff, and then converting it. But it's actually much easier to just use the functions that C provides for these. Zuckerberg asking if I can do printf /n. Yes. So this is kind of the same as this. The only difference is printf could do more characters if I wanted to. So I could say yes stuff /n and this would work, whereas putchar is one character at a time. So putchar and getchar allow you to have minute control over things. I would say getchar is much more useful than putchar, because getchar says I'm going to pull one character at a time out of the human input, which means you get to see all the spaces, you get to see the new lines and stuff like that, where scanf is going to ignore those. Fputs and fgets are similar kinds of things. I mean, fputs I still find really useful because you can dump an entire string in a single small line like that. And printf's not that much different. So when I say printf %s of argv I think that's going to do exactly the same thing. Yeah, it is. So these functions are equivalent, but they may have different uses at different times. I think the ones that come in really handy are the fgets and the getchar, because fgets allows us to grab an entire line of text that's been typed in, but we will get all of the characters. Scanf can never get all of the characters, because if you do scanf on a %s, it will stop when it sees a space, and it will never pull the space. It will just take the letters. So fgets is really useful for that, and getchar is really useful because you get them one character at a time. So if you're not caring about bundling them into words and things, then getchar is really nice. Yeah, so I've used the example of the ones that have really easy equivalents with printf, but when you're taking in input, these ones have more subtleties and more potential use. Oh, right. Okay, so Mingju was asking about padding left, but it's not due yet, so we can't necessarily give the entire solution. So okay, so one idea is like, when would we use getchar versus when would we use whatchamacallit, scanf or something like that. So let's start another demo, because I know these like little library functions are all very fiddly, and I should say that you don't really need to focus on these library functions. Again, there is an idea about what is fundamental to computer science and what is fundamental to programming in C. Programming in C is a very small subset of the entirety of computer science. So some of this stuff is just programming in C. So knowing how argc and argv works is more about programming in C than it is about the overall feel of computer science. Knowing how to use specific library functions, similarly, it's how to use the C library. I mean, I'm happy to teach it, But in terms of the big fundamentals of what I think you should know, that's why these things haven't gotten that much coverage in the course. Whereas the whole idea about how to solve generic problems with programs is more of the focus. But anyway, let's let's have a quick look. I'm going to let's do a getchar demo. So the way I'm going to make this work is I'm coding fast here as well. Usually I would have more stuff in the comments as well. So my user is going to type in a sentence in camel case. I don't know if this is... I'm saying this now. This might bite me. This might bite me by being really long and difficult. But I'm going to show just the starting point, at least, of this. So, user will type in a sentence in camel case. We will split it into separate strings. I'm not going to do all of this, by the way. Because this actually... this could be a decent question 5. Actually, I don't know. No, it's not hard enough for a question 5. It's actually pretty easy. Could be a question 3. We don't usually put strings in question 3. We keep it simple, but you know. I'm not going to use any command line arguments at the moment. So my plan for this is read in the line of input. And I'm going to do that with something like fputs, maybe. fgets. Read line of input. Loop through and split the line whenever we see an uppercase string. Character. I think that's all we're going to need. We're going to need something to contain it. Array of strings to contain words. I'm going to do this simple and I'm going to do this dirty. If I wanted to do this properly, I would make this a linked list of pointers to strings. But I'm just going to do an array of strings because it's quicker and easier. Talking about memes in the... Dimitri says thank you for the memes. You know, that's actually Tom. Tom was like, why don't we put memes in? And I was like, really? And so we were back and forth on it and stuff. And it's like, I think all of the prac exam memes are Tom's. I think only one of them was something that was really similar to one of mine. But yes, we will probably have a meme switch in the exam as well, just for fun. We don't want it to be like super overly complicated or anything. Okay, so let's do something really simple where we have... we learn how to type first. Max word length of, let's say 50. 50 is going to cover most words. I just did exactly the same typo. You know those typos you get where your left and right hand move at different speed? And then the number of words, we're going to assume that the sentence is not going to be very long. So let's just say up to 10 words. So if we want an array of strings to contain these words, it's a character array. Words. So it's going to be a two-dimensional character array with the first one being the number of words and the second one being how... I don't want that. Max chars is better. It's easier to read this now. The maximum... So, here's the number of words. In fact, I should name these similarly, but this should be the maximum number of words. And this is the maximum number of characters. And then we have a character array I'm going to call it input line. I don't know how big this should be. Oh, wait. There's another way I can do this. The input line, the maximum size it can be, is the multiplication of these two. I think that would work, but I'm not 100% whether my compiler is going to like this or not, because compilers don't usually like an expression being the size of an array if it is a variable expression that could change when it runs. This is not a variable expression, it's always going to be 500, but it may or may not be okay with this. I'm going to compile this just to check. So sometimes I'll compile to see if my syntax is correct. Unused variable, that's okay. I do have a lot of unused variables because I haven't written any code that uses them yet, but it is accepting that I can make this array, so that's okay. So that's my array for the line of input. So I'm going to read in the input. I'm going to use fgets, because fgets is going to read the entire line of input, and it's going to make sure it reads every character on that line. So if I tried to do scanf, then it would read something so long as there were no spaces. But if there were spaces, it would only read up to the space. So I'm going to use fgets to make sure it gets the whole line. Fgets, I'm going to look it up because I forget. Man, fgets is the string it's going into, the maximum size of that string, and the stream that it's coming from. So the string that it's going into is input line. The maximum is this same size here. I probably could have done another hash define for that instead, but it's okay. And where it's coming from is the standard input. Okay, so at this point of the code, I have ready, not ready to use yet because I haven't put anything in it, is where my words are going to get stored, and I have the line, and I have read everything into that line. So now, if I'm going to loop through and split, I'm looping through an array, so I'm always going to start with a start at the 0 of the array, and it's going to be a while loop, and while I is less than the size of the line, and input line I is not equals to the null terminator. So I haven't reached the end of the line yet. And I haven't reached the end of the capacity of the line yet either. Yeah, that's true. Tom's explaining it. The compiler's going to do the math at compile time and say that it can't be variable, so it will compile. Finn's asking if we could hash define that. So let's have a look at that, because I think that's a good thing to look at. Can we hash define? Oops, sorry. Max input as max chars times by max words. So this is a question of whether this and this would be seen as separate entities. And Tom's putting a clarification there, is just to be careful with this, is if we are going to do that, put brackets around it. Because if we were to use this hash define somewhere else, it may not end up being this, because we could have maths on either side of this text when this text is actually copied in here somewhere, and it could cause weird issues. So putting the brackets around it means that if we're going to use max input somewhere around here, it'll definitely calculate this before other parts of the maths. But I think that's a cool idea, so let's use that. max input, max input, max input. So now we're going through the input line, one letter at a time. I realize now that I didn't use getChar. It's a getChar demo, and I just read in the entire thing. Okay. Better way of doing this. I'm not going to read the entire line of input. I'm going to ditch that entirely. I love it. This is so funny. Which means we're not going to have a max input either. Sorry. Oh, should I show it both ways? Okay, I'm going to show it both ways. Okay. So this is the easy way. We're going to read through the line of input. And we're going to say, there's two conditions we can have. If input line I is an uppercase or lowercase, so I think is enum, is alpha, is control, is digit, is lower. Cool. I have is lower and is upper, so I'm going to use those. They're part of C type, so I'm going to need to include that. Okay, ctype.h is going to say if this letter is upper or lowercase, we're going to do different things. So let's just go for is lower. Oh wait, it's all... You know those arguments we were having between snake case and camel case? Well, we can go look in the C standard library and they use neither. Okay, so here, letter is lowercase. So if the letter is the lowercase, add this letter to the current word. Else letter is uppercase, add this letter to the, move on to a new word and add this letter. I'm wondering whether I can be bothered writing this code, because I know this code's going to take a fair bit longer for me to write. But the way that I would go about this, in fact, I'm not going to. I'm going to talk about it instead. I'm happy for you to go into the nitty-gritty to implement the way that you would do this. So the way I would do this probably is I would have int current word equals 0. I'm going to end up implementing on it. Int current letter equals 0. Actually, I am implementing it because it wasn't as hard as I thought it would be. So words current word current letter is equal to input line I. So I've read something from the input line and I've placed it somewhere in my two-dimensional array of words. So this is, I'm going to start at the first letter of the first word there, and if it was lowercase, it becomes that one. And then after I've done that, then I move on to the next letter of the same word, current letter plus plus. If I'm going to add it to a new word, then what I'm going to do is say my current word moves on to the next word before I start, and my current letter goes to the start of the new word, and then I say, actually I'm going to copy the whole lot. So then I say the first letter of that word is the letter that I can see, and then move on to the next letter. So this, I love how I said this is going to take ages, and then it turned out to be like 2 minutes. Yeah, and people are asking about the white space. Like, does scanf just throw away the white space, like the new line and stuff like that? Yeah, it does. It just grabs the stuff that matches the format that it thinks, and then it moves on. So what I've done here is I've just done some tricky array stuff to move where I am in this 2D array. So if, hang on, I'm going to draw this. So here's my 2D array of words. I'm just going to keep it really simple. So this current word, CW, is going to move down here, and current letter, CL, is going to move across these. So at some point, I'm going to start here. That's my 0, 0. And then I'm going to put a letter in here. And then I will move my current letter, but not my current word, if I get lowercase letters. So here, I move the current letter, but not the current word if it's lowercase letters. If it's an uppercase letter, I move current word, which means that if it was an uppercase letter, current word would move. Oh, actually, let's say current letter. So it's hello. So H, and then the next one is lowercase. It goes here. Next one's lowercase. It goes here. I ran out of characters, so I'm just going to spell it badly. Yeah. And so my current here will be current letter will be equal to 3, and current word will be equal to 0. If I get a capital letter, so let's say I got a T for hello there, the T would end up down here because it's a capital. When it's a capital, current word moves, which means current word comes down to this one. And then current letter gets set back to 0, so it goes back to the start of the word, and then it writes it in there, and then current letter moves along. So it writes it in there, and current letter moves along. So this becomes the next letter that we're trying to write. If it's lowercase, so lowercase comes here, but uppercase will end up here. So that's one way that I can grab a string and split it into parts of this kind of two-dimensional array. So that's one way that I could do this. Let's look at the other way that I could do this without reading the whole line of input, but by reading individual characters at a time. Which is actually what I was thinking I wanted to do in my head when I started implementing this. But then as I did it, I started doing it with the whole line instead. So what's the demo of fgets now instead? I wonder how I want to do this. I might just start a new file for this. I'm also going to change the getChar demo to fgets. Did I? Oh, I spelled it wrong. Because getChar doesn't actually have a capital C in it. Okay, so that's now an fgets demo. getChar demo. Alright, starting a new file for this other one. What did I? Oh, wait. I'm just going to close that. Yes. And we'll start a new one, but I might also open the fgets demo because I might want to copy some of the code from there. Okay, so this was the code. I'm going to steal a bunch of this, and then I'll just delete the bits I don't want, because I'm still trying to do this quickly so I can show you things. Okay, so I've got some of the same stuff here. I am not going to define a max input because I'm not taking all the input at once. I am not going to read in an entire line of input. I am going to do some of this splitting stuff. So what I'm going to do is just move this stuff down, and I'm going to pick and choose from it when I want the code from here, and I'm going to remember to I'm just going to remind myself. This is what we do a lot of the time when we're midway through something. And you may have found yourself doing stuff like this in your assignment, where you leave a note for yourself saying, okay, I wrote this function, I don't think I'm going to need it, but I might need parts of it, so I'm going to delete it later. So I'm just leaving a note for myself that this entire section here is something I'm probably going to delete. So what am I going to do here? Read in one character at a time. Split words if they're capitals, otherwise add them to the current word. So this shouldn't be too bad. Like, I've got current word, current letter. I'm going to use those. I'm going to Control X them because I think I'm going to use them. So current word, current letter gets us into this array here. And so what we're going to do now is we're going to loop. And we're going to loop with getChar. I'm going to need a current character. Current character. I'm going to do something tricky. I'm going to define the current character as a null terminator, just in case something goes wrong and I can't pick anything up. At least it'll have a value, but it'll be like an empty value, so it sort of works for me. So I will getChar. Let's look at getChar. Standard IO, I've got that. getChar void returns an integer. getChar is equivalent to getC standard in, equivalent to fgetC, which reads next character and returns the character cast to an int or EOF on end of file or error. So while getChar is not equal to EOF, so I know that it returns EOF on error or end of input. Wait, I can't just call getChar without giving it a somewhere to store it, which is my current character here. So I'm going to get even trickier than what I was doing. This is what happens when I don't prepare things as much in advance. You get to see my decision making live. And when we're coding live, well, not just coding live, when we're coding in general, we're going to do a lot of this. Oh, I had this idea, I started implementing it. It's not exactly how I want things, so I'm going to re-implement it. So here's my getChar. So what I can do now is current char is equal to getChar. So current char will be set up as the first character that gets typed in, so long as there is a character that gets typed in. So then I can say current char is not equal to end of file. So long as current char wasn't end of file, then we'll run whatever's in the loop. So run the loop if getChar picked up a real character. So if getChar picked up a real character, not an end of file, or not the end of the input, then we can run stuff with it. And so if we're going to run stuff with it, we can actually run this bit of code here. So I'm going to Control X that to cut that and paste that here. I do need to make some changes here because it's no longer an input line, but it's the current character. So if the current character is a lowercase, then it goes in the current word, current letter, like we did before. And then we move the current letter along, which is that integer, which is an index of where we're going. So this one is storing a character that we got as the input. This one is storing an index, and this one's storing an index. So even though they're all integers, they're there for different purposes. So there's the current character goes in there, and everything that we had before about moving these around, as we showed here, lowercase, it keeps adding to the same word, uppercase, it starts a new word. All that stuff is still happening now, but it's doing it one input letter at a time. So we have our while loop here that runs once if it picked up a real character, and then it's going to check the current character again, which means we need to give it a new current character each time. Current character equals, let's get the next character. So this is a way that we can use getChar to pick up individual characters at a time, and then only if it sees the difference, if it sees something that is not a lowercase character, it splits the word. Which means that I think it will split words not just on camel case capitals, but it's going to split words on anytime there's a digit, anytime there's a space, anytime there's an invisible character like a new line and stuff like that. So this is kind of going to be like lowercase characters, and then anything different starts a new word, which is kind of okay for camel case, I guess. So that's an example of how we might use something like getChar in a loop. So we get characters one at a time using this loop, and the loop will stop if the character, if the input finishes, but otherwise it's going to go through and pick up individual characters and use the individual characters to do different things. I'm not going to go too deep into this. I could write all this code to print it out and stuff like that just to see it working, but I don't think we necessarily need to do that. If you want to, I will chuck this demo code in the lectures section. You can play around with it if you want. I'm going to delete this because I know I don't need it. So Tom said refactoring time for this code, I think. I think that's what you were saying before I started the new file, right? Tom and Liang are working on some code between the two of them there, I think. Tom's saying you should never scan with a %s. It's weird. Scanning with a %s allows you to go outside of the memory you've defined for things, if I remember correctly, Tom. And that can lead to the possibility of you writing over code that's in your stack to do things. Both have the same issue lines 22. Oh, that's not me, is it? You're talking about Liang's code there. Unless this is wrong? No, I assume that you're talking to... Wait. No, you're talking about mine. I'm not sure, Tom, you said the line numbers there, were you talking about my code? Because it might be, because those lines match up. Oh. You want to refactor this part here. I'm not sure exactly what refactoring you're wanting there. You can let me know if you want, but I think it's probably better that we look at some other questions other than just the character input stuff there. Oh, I'm repeating code. Right. This and this are the same. So what I could very much do, because they're the same, because both paths lead to the same final outcome, we can put that outside. Yeah, I get where you're going now. I thought that there was something else. But yeah, now that I see it, yeah, very much so. I'm going to do that here as well. Because the final bit that both of them do is exactly the same. Okay. So, one thing... yeah, as Tom's saying there, a lot of times when people write stuff, they write repetitive code in multiple places, and that can lead to errors because this thing that was making the current letter appear somewhere and then move the next one along was something, when we repeat it, it can lead to issues when we change one and not the other, even though they're meant to be identical. So if 2 bits of code are meant to be identical, then there should only be 1 bit of code. Okay. So one thing that Tom was suggesting is maybe we should have a look at the current prac exam. Finn's got a good point here. Now that we've seen that the if is lower is actually empty, which means it's unnecessary to run that at all. So we could swap that around to is upper and say if it's uppercase it moves on, if it's otherwise, and for both cases it does this. And then my code suddenly starts to shrink into something that's really nice and manageable now. Do the same thing over here. Okay. That just got much smaller and easier to understand. Okay, let's have a look at the current prac exam. I mean, it is due tonight, so we're not going to write code. And Tom's saying that there is a potential issue that, oh yeah, no, that was fine. I was kind of throwing in the idea that we could split on anything that wasn't a lowercase letter, which means we were actually dealing with snake case and camel case in the same example, except numbers. We were splitting also on numbers, which was awkward. Okay, week 10 lab here. And we have the prac exam. Oh, speaking of which, can people please fill out the survey? I'm assuming that people who are hanging out here in a special extra stream have probably already filled out the survey because you're keen in doing things. But if anyone hasn't, please fill out the survey. We need to get as many responses as possible so that we get a good statistical spread of people telling us about the course. Okay, to access the prac exam, we go here. I'm pretty sure my username and password will work here. I'm not sure, but I'll try. Oh. Give me a second. I just don't want to type in my password on something that I'm not sure is definitely going to obscure the password. So I hopped off that. But Tom, do you have a login that I can use? All right, cool. Here's a prac exam that we can have a look at. People are asking a few things. Duke's asking why you can't see the Lab 10 solution, the Week 10 lab solution. The Week 10 lab's not even due yet. So the solution won't come out until after it's due. It's due at about 8 p.m. tonight, which means we're going to release the solutions to that very soon because we want you to have the solutions before the exam. The weekly test is the hardest one because it's due on Thursday. I think we pushed the due date earlier on Thursday so that we could release the answers to you Thursday evening. So you at least have just a couple of hours to look at the answers before the exam hits you. Peter's saying that you don't know how to do night moves, but using an exercise and making an ADT. Yeah, you totally can. You can build up some nice things. I think it's very hard to do without some structs. So you can build up structs for doing linked lists of the future. So that's one way I would do it. So like every move leads to other moves, that kind of thing. But we'll talk about that if I have time afterwards, although we've only got 15 minutes left, so we don't have that much. Okay, so this lab is due at 8 p.m. tonight, this prac exam. So I'm not going to write code to answer these questions, but we're going to have a look at some of these and talk about at least the difficulty level of this and how it works. So short answer question like this, part 1, this C code is in a program. It has an int x, which is 11, and an int y equals 3, printf x divided by y. So if you want to, this is very easy to do. You can grab this, Control-C that, copy and paste that into your gedit, run this code, see what it prints out, type that answer into the, where is it called? pracmc.text. And then that will be the answer, and that will be the correct answer. So I should be... oh, Peter, I apologize. I didn't say you have to use a linked list. You can totally use an array. There's plenty of places where an array or a linked list are going to be just as useful, especially in something like knight moves where there's a finite number of moves. Like a knight's going to have a finite number of moves. You could use an array, not a linked list. So please don't take that as me saying you have to do it one way or the other. That was me just offhandedly throwing an idea out there. Yeah, so I go to my pracmc.text and write in the answer. So the difference in this question is, are you quick or not? So I can do this quickly because I know that integer division is going to give me a particular result, so I'll just write that number in. If you're unsure of yourself, copy paste it into a file, compile it, and run it. Because then what we're testing is your ability to compile and run things as well. So it's a one way or the other, in a sense. So you can get a mark from this for knowing how to use gedit, how to use DCC, and how to run a program. If you don't need that mark, if you're confident that you know how to run a program, then you get this mark based on can you do integer division in your head, and can you remember that integer division has subtleties. Question 2 is going to be similar to question 1 in terms of oh sorry, no, this isn't the same as question 1. So this isn't the same as question 2 in the actual exam. This is different. So this is something where we might ask you a style question. So we say, this this program has some issues with style. There's something in this that's making it difficult to read. Which of these things are the issues in this code? So we can answer more than one thing here. So your answer can be, for example, A and C, if you think that A and C are both correct. Or if you think there's only one answer, it could be D. So for example, if I think there's inconsistent indentation and there's overly deep nesting in this thing, I would answer AC. If I don't think those are problems, but I think bad variable names is a problem and there's no use of constants that should be used, then I would answer BD. If I think all of these are bad, then I would answer A, B, C, D. So this is one of those ones where it's like really variable. Raul's asking how much nesting is considered overly deep. If it's hard to understand, I would say overly deep nesting becomes a problem with understanding somewhere around 4. But I would also look at it in context. So some things become nearly impossible to understand around nesting level 3 or 4. So if I have, say, a three-dimensional um, linked list of weird stuff going on, and I nest it just like 2 or 3 levels, that might be enough to throw people off. If I have something really, really simple that I'm working on, and then I do while, if, while, something like that, then it's potentially an issue, but you could get up to 4 or 5 before it's overly deep. Here, I would say there's definitely not an overly deep nesting issue because this needs this level of nesting to function, right? It's just a single while loop. This is only 2 deep here, and this level of nesting I would nearly not even consider what's inside the main to already be one nest. I would say this is like 1 level of nesting. So in this question, I would not answer C. But maybe there's some other stuff that I would answer here. Just looking at it, I'm just not sure what the monkey stands for. That's a clue, I guess. I'm not going to give away the answers. But I mean, you know, you can look at it and you go, okay, some of these things feel weird to me. Some of these things feel like they're not super readable. That's where you'll get the answers to that question. Okay, and then we have another question here, which is about memory allocation of a struct. So we have a struct here, and we're creating a pointer to a struct called head, and we're memory allocating that struct, and we say, okay, what are we going to put in here? So what do we think is the correct thing to put into this if we're going to get a node pointer as the variable type that comes out of the memory allocation? So have you remembered the sort of golden rule for how I was allocating memory every time I allocated it? You can type that in there. If not, go back through the lectures and go, okay, this is how we work with structs in memory. Oh, I can give the answers to these because they're not actually marked. So these ones are not going to give you marks for your labs because they're just simple questions. Okay, so for this one, I would say inconsistent indentation. Let's have a look. I think there's a problem here, right? Because there's this number is being edited and this one's going in a different indentation for no particular reason. Bad variable names, I would consider this potentially. I would probably answer B to this because monkey has no meaning in this context. I have no idea why. I mean, I looked at it and went, why is this monkey? It's not even like the name of a monkey or something, it's a number, so I'm not sure. And it's a total. If this said the number of monkeys is this, then I would say, okay, that's why that variable was called monkey, but no, it's just weird. So I'd say yes, bad variable names. Overly deep nesting I would not say is a problem. I don't see anything going too deep here. I can understand the code structure just by looking at it. Lack of use of constants, I probably would not say this is an issue because there aren't really any magic numbers. There's a 1 and a 0, but I think they might be, I can't really see the context, they might be relevant starting numbers, but someone has decided that you stop at 100 there, and so they've used a constant there, so I'm not going to say that. So I would probably say for this one, the answer would be AB. And then this one here, malloc, I would always use size of the variable type that is being allocated to this pointer. So struct node pointer, this would be size of struct node in here. People are asking... Duke Yang's asking if we have auto tests for the short answer questions, and Tom is saying, yes, we do. You do not get told whether the answer you typed in was correct or not, but you get told if it's the right format. So, as in, it'll say, for this one here, if I type in, instead of I said it was AB, so instead of me typing in AB, I type in inconsistent indentation and bad variable names, the auto test will say this is not the correct format for this question, just give us the letters. You know? So that way, you're never going to get marked wrong for a question because you typed the input in incorrectly, right? When you type in the input incorrectly, it's going to read it and go, are you sure? Because that doesn't look like the kind of input we accept for that question. Okay. So practical questions. these ones are going to be part of your lab marks this week, but I'm going to talk through them at least. I mean, like the same amount of help that you could get in the lab itself from your tutors last week on this. So, reasonable thing for the arrays hurdle, the first question in the exam, is we might give you something that we expect that anyone who spent a significant amount of time with freefall assignment 1 should have had enough experience with to be able to work with this. So if we have the ability to work with an array like this, then we have this kind of question. So count small says we have an array that is a square array which has test array size, and says an integer that is put in to say what the size length is. It's going to give us a square array for sure, because we know that these are the same value, and this will tell us how big it is. So what we're asking for is add code so that count small returns a number of small values. A small value is between -9 and +9. So what we're going to do here is we're going to be asked to look at every element in the array exactly once each and count how many of them are between -9 and +9. And I don't think that that is very difficult in terms of code. Like, what we're going to do is loop through the whole array. So you're going to need to know how to loop through a two-dimensional array. If you need sample code for that, there's sample code for that in the lectures, so I'm not going to write it now because you should be able to find it. And the thing that we do to test each individual element that we see is we say, is it greater than or equal to -9, and is it less than or equal to +9? Then it is a small, which means we count one more small element. So somewhere we're going to need to have a counter that is counting how many small elements there are, and at the end we return how many of them there are. You don't have to say what they are, you just return the number of them here, because it's just an integer. So I think that this is not too hard. Basically this is saying, have you looped through all of the elements in a 2D array before? If you've done assignment 1, you definitely have looped through all the elements of a 2D array. If you can loop through all the elements of a 2D array, then you could run an if statement on all of the elements of a 2D array. If you could run that if statement, then you can you can get a result from that, and you can store that result in an integer, which is counting up the values. So yeah, that's a question 1, and you can see how that's kind of fundamental. The things we're asking you for are, can you loop, can you run if statements, can you work with arrays? So that's the basics for a question 1. Question 2 here says, I have a linked list. So you will have a node structure that has a next pointer and the simplest possible data we could put in it. So the early questions are not going to have complicated data. They're just going to have something like a number in it. So it could be an integer or a double or something like that. You know, like one of the basic variable structures. This is where we're not testing you on complex variable structures. We're testing on whether you can use linked lists. And this one says count even. You're given one argument, which is the head of the list, and then you're supposed to loop through that list and say how many elements returns the number of even values in the linked list. So what I would do with this is I would use the code that I know. If you've done assignment 2, you can loop through a linked list. If you've been in the lectures or the linked list stuff, you can also loop through a linked list. We've done that several times. I've even given you code for looping through a linked list in the lectures. So it should be, the code's available if you need to refresh yourself on it and make sure it's working correctly. But what I would be able to do then is loop through this linked list and look at these numbers. And again, very similar to this. I look at each element of the list exactly once. I run an if statement on that. If that if statement comes up one way or another, I will add to my counter. It's not always going to be add to your counter. It might be loop through and do something else. So you might not always be counting the number of things. Sometimes in these questions we might say, for example, loop through and stop at a certain point or something. But that's going to be the same thing. You loop through and look at each element and have an if statement, right? Yeah, so this is pretty simple. I would loop through, and you can see how we're testing something else here. So we're not just testing, this is if greater than or less than. This is testing whether you can figure out whether something's even. And that is whether something is cleanly divisible by 2. So I'm not going to say anything more. So, but you know, I think a lot of people can guess how you would find an even number. I think we've had examples of this as well. I'm just going to say it. You'd use a mod. So when you can piece together that kind of thing, you can see that we're testing, can you figure out how to loop through a list? Can you do an if statement on every element in the list? And can you test a particular condition? Can you count up stuff? So both of these happen to have counting in them. It won't always be counting, but counting also tests whether you know that variables inside a loop and variables outside a loop are different. Because everything that goes on inside the curly braces stays inside the curly braces. So the variables that are inside a loop exist only for one run of the loop. If a variable exists outside the loop, so if a variable was declared outside a loop, it's the same variable, and then the loop runs multiple times, and it can change that variable every time it goes through. But if the variable's inside the loop, it lasts only one through, right? So, yeah. So knowing that is also handy. And all of these little things that we've been teaching you over the course of the term, we might throw some of those in here. Not the super hard ones, but things like that, which is like, if I know how variables work, if I know how loops work, and I know the basics of linked lists and arrays, I will be able to answer these 2 questions. Note that in neither of these 2 questions do you even have to create an array or a linked list. So it's very unlikely that in question 1 and 2 we'll ask you to make them. So it's just, can you use them? So you can see how the hurdle is not very high. You could potentially have just been sitting in and watching lectures and never even gone to labs, and you could still probably pass these hurdles. Those are the questions that are happening there. Oh, people are asking me how to become tutors. Okay, I'm gonna leave that for the moment. Okay, so I've got one more thing here. So we didn't put in a question 3 here, but we have a question 4. So the question 4 here will be the other linked list hurdle. You don't need to pass question 2 and question 4. Question 4 is also a hurdle just in case someone has a big mistake and it's an accident in question 2, but they show that they can use linked lists in question 4. Because question 4 is undoubtedly harder than question 2. So usually, like there's hardly ever a situation, but it has happened, there's hardly ever a situation where someone can't solve questions 1 and 2, but they can solve question 3 and 4. Usually the way that works is only that if someone made a huge mistake in question 1 or 2, but they obviously know what they're doing and they show it in question 3 and 4. Oh, Tom's talking about how he got a 68 in something and ended up teaching it. Okay, so question 4 here has a linked list node, and it says count matches, and there's one node here which is the head of one list, and there's another node pointer which is the head of the other list. So it's saying given 2 arguments, head 1, head 2, which are pointers to the first node of linked lists, add code to count matches, so it returns how many places the 2 lists have with the same value in the same position. So the 2 lists contain these values. It would return 2 because the 1 matches there and the 9 matches there. So what we're asking for here is if we have 2 lists and we put them above each other, can we loop through both of them at the same time and check them against each other? So this is something that could be done in a reasonably simple way where it's a single while loop that moves 2 pointers at once. And so the 2 pointers move along the list, and each of the pointers is going to be looking at a node, and you check the contents of the nodes to see whether they are the same or not. This happens to also have the thing where you're counting the number of times something happens. Question 4 is not necessarily going to have just the same counting thing, but you can see how this is significantly more complex than question 2. Can we, because I don't have code that gives you this for free somewhere in the lecture slides, can you maintain a loop through 2 lists at once and see what elements you can read there, and can you test elements from one list against elements in another list, right? So there's a lot more going on here. And you can see this is the escalation of difficulty. I don't think we put it in here, but in the lab exercises, there's also an example here of night moves, which is the hard question. This was a question 8 back when we had 8 questions. Now we have 7, and so the hard question is the 7 rather than there being a 7 and an 8 where there were 2 hard questions. And so we've got the squares there. A knight moves by moving 2 spaces in one direction, 1 space in another. What we want to see is like how far they can reach and what paths they can reach and stuff like that. I won't necessarily cover that now because we're past 4 p.m. But let's see what was... There was a request there from Sunny. Can you go over what files to include in compiling for multi-file projects? So I think this was a test question. So this is a weekly test question. Duke's asking you about practicing question 5 and 6. I would say hard lab questions and challenge questions. Not even... Oh yeah, some of the challenge questions. But some of them are actually just the hard questions in the labs as well. Duke's asking if we can access the term 1 exam. We don't publicize previous exams. Because the format is reasonably similar. What people are asking is the same kind of thing. It's kind of like we give you a lot of it. Some of, not the term 1 questions, but some of the questions from previous exams are actually weekly test questions and things like that. But we're not really giving out the exact, like we're talking about the exact format of the exam, but not the exact questions, in case some of those that are very similar to those are going to get used again in different ways. Yeah. Oh, Tom's saying maybe we want to look at the current weekly test. Did we actually have the multiple choice questions in the weekly test? I can't remember if we did that or not. Someone's talking about recursion. I did mention it. Yes, there are definitely scenarios where recursion would be useful. I mean, even in COMP1511, there are several places where recursion could be useful, but we just didn't teach it because there's not enough space for all of the possible topics that we could teach. Oh, okay, so Tom added some multiple choice questions to the current weekly test. I thought I'd looked over that, but I think I must have looked over it before you did. Okay, practice short answer questions here. I'm going to view in browser so that I can actually see the whole thing. Okay. Uh-oh, I've only got 4 minutes left of reading time. We have gone overtime for this stream as well, by the way, but I'm just going to keep going while people still have questions. Finn, fire him! I fire Tom all the time. It's considered a mark of honor within the COMP1511 teaching staff if you've gotten enough attention from me to get fired for something. Liang is saying this is still not due yet. Yeah, this isn't due till Thursday. So I'm going to only look at the short answer things here because I'm pretty sure the short answer things probably won't have marks attached, Tom. Am I right? And then there'll be 3 separate questions, which I will try not to scroll to so I won't spoil it in case anyone hasn't seen it. Having said that, I would highly suggest doing the weekly test because it's like the lab in that it has questions that are exactly the same format as the ones that are going to be in the exam. So, well, not I mean exactly the same format. They're not asking exactly the same things, but they're at the difficulty level and they say what the difficulty level it is. Yeah, so these don't have marks. So, imagine you have been given a file, test 10, question 1, which contains this. Print, hello world, I am this many years old, age, int age equals 3, return 0. Which line is the first that contains an error? So, we look at this and we go, okay, knowing what we know, oh, hello, someone's come to say hi. Say hi to everybody. Hello. Oh, look at her. She's been having a nap on my bed for the last like 2-3 hours or something, so she's still pretty drowsy. There we go. Little nap time. Okay, so I would say that there's no errors up there. I mean, there should be a space between that and that, but that's different. It looks like we're trying to access a variable before it exists, because this variable hasn't been declared, but it's being used, which means I would say that the first error is on line 4. Line 4. So it says first error is line 4. Okay, that's fine. And then this one says, imagine you've been given a linked list which is defined as data node. Oh, we should have put some enters as new lines in here. But anyway, this is still legal C even without new lines. You've been asked to create a type def named node, capital N node, for a pointer to this struct. Write the line of C code that would define this type def. So this is something that we have looked at least a little bit about what a type def is. It's going to allow us to say, okay, here's a variable type that exists, but we're going to use a different name for it so that it doesn't have the implication that it's a pointer to something, because we're not actually giving access to that pointer. So we might do this. Type def struct node pointer is actually capital N node. So that way we can say, okay, we're going to do it this way instead. And that's something that we've looked at a bit in our abstract data types as well. Is Chicken just like aiming her butt at you? That's how you know she likes you. I think she just wants to sit there. She likes sitting on the side of my chair while I'm doing stuff. Alright, and we have this other thing here. Your partner has written the following line of code. A square brackets 3 is equal to the character Z. They have asked you to write a definition of A. So, knowing that it's going to be used in a certain way, this A, what could it possibly be? So, let's assume that we have a hash define for size and its value 10. Which of these are going to be able to work like that? So, if I need to declare A, which of these things will make this snippet of code legal code and working code? So I could say, if A is a character array of size 10, then I can access element number 3, which is the 4th element in this list. That one seems to be okay. This one, character A is an array of size 2. If I have an array of size 2 and I access index 3, then I'm in big trouble, right? Because index 3 doesn't exist. Index 3 is the 4th element of the list, but this only has 2 elements. So I'd say B is out. Character A is a pointer to a character somewhere. Pointer to a character could be seen as a pointer to the start of the memory for a string somewhere, and maybe we could access the third element after that. I'd be careful of this one, because you'd need to write more code than just this to make sure this thing works. And the extra code that you potentially write is right here. So if I knew that that pointer did have memory at the other end, and that memory was the size of a character times by 10, which is the same thing as saying it's an array with 10 characters in it, because we can have size of a character and the number of elements. I can say memory allocate that much for me. I would be able to then access the fourth element in there and put something in there. This one I'd be dubious of. I think the answer that I would give here would be AD. Let's see if I'm correct. AD. There you go. Because yes, this technically gives access to memory somewhere, but if you haven't written any more code for that, then you're not sure whether that memory is actually yours to use. This is a pointer to a single character, not necessarily a pointer to a lot of them where we can go further into memory. Whereas this one specifically has said we can allocate this memory here. So yeah, A and D were my pick there, and so happy that I was correct there. People are talking there. Is it possible to make a directory and change to that directory in one command? I don't think so, because I think the command is going to set up all of the possible locations it can do stuff and then run, in which case the location you want to move into doesn't exist until after the command is finished. It would be interesting to see if there's someone who's like a terminal slash shell. Shell is the language that the terminals use. Genius who actually knows a way to do that in a simple way. Because I think it could be done, but I don't think there's just a straight out command that does it. Yeah, you can do, whatchamacallit, you can do scripting. You can run a script that would do that. That would look like a single command, but actually be running multiple commands. Okay, which of the following variable names would compile without errors in C? So we're looking at which of these are completely valid variable names that C likes. Trick to these questions, if you're unsure in a multiple choice question like this, and you need to test it, you can, because this is asking whether it would compile. So if I was feeling unsure of myself, I will copy paste all of this text in, put the word int in front of each of these and see which ones compile and which ones don't. I'm going to look at this via the rules that I know, however. So I know that I is a variable that I can use, definitely. So A is definitely in, because they're saying would compile without errors. This looks fine. It's starting with a lowercase, but I mean, actually it doesn't even need to start with a lowercase. That's a convention, not a rule. Underscores are fine. We use underscores a lot when we're using snake case, so I think that would compile. This one I have more of an issue with. This is a symbol. The hyphen is not used necessarily as a hyphen in C. It's used as the symbol for minus, which is a mathematical operator, and I think that the C compiler is going to have an issue with me using a mathematical operator as part of my variable name. Here, chicken, it may be partially in leet speak, but it's still going to be a valid variable name because we can use numbers in variable names, and starts with normal letters, which is fine. E, I do have an issue with. You cannot start a variable name with a number and expect it to work. You can put numbers afterwards, but if you start a symbol in C with a number, it's going to expect, again, the same idea with this hyphen. Here, it's going to expect some kind of mathematical operator. So I think that I'm going to get A, B, and D as the correct answers here. If I wanted to verify this, I could always check. So there's a lot of things in the multiple choice which can be quick answers for you if you know the answer, and can be longer answers for you if you think you need to verify. You can go run some code and see if you can test similar examples and see. So I'm going to say A, B, D and see what the answer is. Yeah, A, B, D. This is much more funny if I get these wrong, actually, by the way. But I've got them all right so far, so that's all right. Okay. I'm going to not scroll down to there. I just showed the title. Okay, so this last one here. Imagine you are compiling a multi-file project, main.c, includes list.h and capture.h, and contains a main function. So that's the main.c contains the main function, includes the h for list and capture. And then we have capture.c and list.c are also in that directory. So if I think that this is how my setup is, I think that someone's named all the files correctly for this. I need to decide which files I need to compile in order to make this project work. So if I I won't bother searching through. It's back in my slides. It's a long way back in my slides. We talked about compiling multi-file projects. So one of the things that we learned when we were compiling multi-file projects is everything in the C files gets compiled, and everything in the H files gets used if it has been included in one of the C files. And then everything that's been included needs to have a matching implementation. So if I'm going to include list.h and capture.h, it means I don't compile them because I've included them already. But if I have list.h and capture.h included, then I need to compile their C files to make them work. Because without the C files, the H is just a front end to something. It doesn't give you all of the working information. So I've included list.h and capture.h, so I know that I need to compile capture.c, list.c. The other thing, one of the files in every project that we compile must have the main function in it. So we have no guarantee there's a main function in capture.c and list.c. In fact, we have a reasonably good idea that they will not have a main function in them because they're paired up with these H files, which means they're there to provide working code for something else. And the main here specifically says main.c includes list.h, capture.h, and contains a main function. So I'm pretty sure we need the main function as well. So I would answer A, C, and E for this one. So A, C, and E is our answer. So that seems to be correct. Oh, hello again. There's a tail here. What are we doing in chat? We're doing shell scripting. Oh god. Okay. I'm not going to go into that. Okay, so I think what I've covered today is a lot of what goes in to the exam in terms of like the multiple choice questions and stuff. Why I went through some of the questions 1 and 2 and things, and there was a question 4 there as well that showed you some examples of what's going to be coming up in the exam. Did anyone have any other questions? Eric is asking if I could go through question 4. Which question 4? Was it the prac exam question 4? Like the lab one here? See which one Eric is on. Of that test. So the one I was in a second ago. Wait, not that one. This one here, this question 4. So this is whether variables will compile or not. And so we're looking at this one as which of these things are legal. Oh, no, I can't, Eric. So I specifically did not scroll down to the questions because the questions they're not due yet. So you'll have to have a look at that. It'll be due on Thursday, and then a solution will be released Thursday evening. Yeah. So, unfortunately, yeah, I can't. Having said that, if you do want help with that one, you can probably... Can we do private questions on the forums at the moment? I'm not sure, but I reckon you could post on the forum and you can get the amount of help that won't spoil it for other people there, which is what we want. Because if I start talking about it now, then it's just like it's public and lots of people can see it, and that just kind of that will take away people's chance to actually study with it, because people are going to want to study with this not knowing what it is. Yeah, it's due on Thursday, but it's due earlier on Thursday, because I think Thursday we'd been dodging the lecture and making it due a couple of hours after the lecture, but I think we pushed it back to its old normal, which was 5 p.m. due date, so that we can release the answers that evening, later on that evening, and you can go back and have a look and see how they worked. Yeah, and as Tom's saying, your tutors are still at least a little bit available to help. I mean, different tutors are busy in different ways. Some of them have exams around the same time you do. But there will be some help, like forums and emailing your tutors. You can still do that for help. Okay, so we're half an hour over the time that I'd planned to do this. Did anyone have any other questions? So I had some questions that I said, let's leave these until afterwards. If I'd said that about your question earlier on in the last 2.5 hours, you can retype your question in now, and I'll at least have a quick look at it. even if that question was, do you play League of Legends? But like, more importantly, any questions that are to do with the course. So I know there was definitely something about night moves, and I can't remember what else there was. You know what I'm gonna do? Where's my new button? Oh, there you go. There was a question, working in tech, the pros and cons of it. I think I covered a bit of that. I think there's other risks in working in tech. Is that one of the things that we can get caught up in working with tech is that we're in what I would consider to be kind of an industry that treats its staff pretty well, has a lot of money flowing through it, and has a disproportionate capability to change the way the world works. So this is something that has a different effect on people depending on who they are. So a lot of people realize at some point, working in certain parts of the tech industry, that they have the ability to damage humans. and it changes depending on people. Like, you can be careful about it, and you can make your code so that it doesn't adversely affect people, but then there's often a lot of ways that you don't realize what you're doing, and then afterwards you find out that this thing that you thought was bringing people together is actually turning them against each other. Have a chat with anyone who worked in the early days of Twitter and Facebook, and how they may have believed that what they were doing was providing this amazing ability for people to communicate with each other, and now we know that all we got was the ability to get into more arguments. It's not necessarily that bad, though. That's just something that some people might want to think about, you know. Also, I just want to bring your attention to what's going on over here, because it's super cute. She's just sitting on my mouse pad licking herself. Danvo is asking how we can submit the multiple choice. That's actually in the lab, the practice lab, about how you write the text in the multiple choice file, and then you can submit it, and I think there's auto tests for that. Yeah, as Tom's saying, you can give there. Taylor, What a question. Do you and the tutors actually manage to catch a break before T3 starts? Seems like a lot of work still gets done during the exam after term finishes. Taylor, you are 100% correct there. In general, I will finish this term, the one that we're in now. All of the admin for this term will be finished, um, whatchamacallit, sometime around week 2 of term 3. I think that's where we're going to be. And that's usually where it is. It's a little bit messy, but we do what we can. Um, oh, Tom, what are we demoing? Oh, Lydia, yeah. Chicken has this habit of patting me. I think she's learnt from us that we pat her, and so when she wants attention, she'll actually pat us, which is like really really cute. Um, let's have a quick look because we can do this. I'll quit out of this. I'm gonna make a new directory. It's probably not a bad idea for you to make new directories for everything that you're doing. I'll go into the prac exam directory. You can see now that I kind of type faster than I did at the very beginning of term, where I'm just tab completing things now. So here's my prac exam, and I'm going to fetch the prac exam. I think it's called fetch prac exam. Oh! What a great response. 1511 does not recognize you as a student, so you cannot fetch the prac exam. Which is correct. I'm not a student of 1511, so I can't fetch the prac exam, even though I am the main staff member for 1511. Oh, Tom's going to try to add me to the list of people that can do that so I can show you the prac exam text file. In the meantime, other questions. Yifan Zhu is saying, what should we check if the instruction didn't show clearly whether the input array or linked list can be empty? I think that no matter what, if we ask you a question about an array or a linked list, you must be able to deal with it being empty. So for example, where is it? Prac exam here, count matches. Note very carefully that these two are different lengths. So you have to be ready for one of them to end before the other. And also, we've said we'll give you a node, which is the point of the first node of linked list. It doesn't say specifically whether it can be empty or not, but I would assume that it can be. Because I've said before that a pointer to null is still potentially something that might happen as the input to linked list functions, and we've demoed that as well. Oh, right. It's because I'm using my CSC account, which is not my standard um, ZID account, and that's a special privilege I have as a staff member. But it's making things go weird for the exam, which is auto generated on all our ZIDs. Um, so I'm just going to see here whether this says anything about empty lists. The lists may be of unequal lengths. The linked lists may be any length. There you go. So it says either or both linked lists may be empty. So this particular question says, yeah, you've got to deal with empty lists. So I would say that in the exam, if the auto tests are not checking for an empty list, you should, because it might be something that's important for the marks. So that was Yifan's question there. Eric says, if we submit the wrong file in the exam, is it game over or will there be considerations? If you submit the wrong file, the exam will tell you that you submitted something that passes 0 auto tests. So in the same way that we're using the give system in assignments and labs and things like that, it will run one final run of auto test on your submission as you submit it. So you can go through the submission, you can confirm it, and then it's going to tell you something about your submission, the way that we normally do. And so that way you can be certain that the submission that you put in there is passing the same auto tests as the file that you're testing in front of you, and then you can say, okay, that's all right, I'm going to leave that as it is. Having said that, if you do massively screw up or something like that, all of the files that you have been using for the exam, so long as you have been auto testing them all and submitting them all regularly, we will have access to them. We're not necessarily going to go, we're definitely not going to go through all of the files that you used, every single file you auto tested and every single file you submitted to check on things. But if you think there's a problem afterwards, we can always look back on things. Having said that, yeah, you're still not going to just magically get full marks for things if we see that you've submitted something and you didn't look carefully at what you tested and what you submitted, because that's still something, you know, we're not going to give perfect marks if you make mistakes, in a sense. That's the way it has to be. But if you're auto testing everything and you're submitting everything often, then we'll have a trail of your progress with things, and we can go back along it if we need to. Like, it's only if there's a significant issue in your marks we need to go back and see what went wrong. So Eric, there is a kind of a safety net. It's not a huge one though, but it exists. Tajwa is asking, is there any difference in the capabilities of character pointer variable name square brackets versus character pointer variable? They're both an array of strings, but not sure which would be used when and where. The used when and where is like, are you in the standard library where they put a whole lot of stars on things? Or are you somewhere else in your own code where you're trying to make it specifically readable in a certain way? Sometimes we might use lots of square brackets, as I did here, because I want them to be a specific size when I declare it. Yes, I know. She wants to talk to me. I'm not sure what about. So there's different ways of doing it, but it's just good to remember that they're all roughly equivalent, but not precisely equivalent. Because if I did character star words and got rid of that, then this is potentially hugely dangerous. Because I said there's a pointer to memory, but I haven't allocated any memory. So I haven't declared a variable for that memory or allocated it. So even though this is functionally an array of strings, it's not good because the variable has no memory attached to it. So this only works if that memory has been created somewhere by some other part of the program for use. Whereas this is explicitly saying, give me that much. I want that much memory within this set of curly brackets here, just like a variable. And this is how much of it I'm going to use. Okay, what do we've got here? Duke Yang is asking if we have a recording for today. Yes, I will put this up on my YouTube. Danver is asking me if I can copy the code in the short question to see what happens. Which short question are we referring to here? Is it the variable declaration one, maybe? Eric is asking if we can use... Oh, that was in general from the short answer questions. Yeah, totally. Yeah, like if you want to verify things, you want to be 100% exact on them, you can copy the code from the short answer questions and do anything you want with them. You can verify different parts of it if you want. Yeah, nothing wrong. Like there's no limit in the exam to what you can test. You know, you can write any code you want. The only limit is the 24 hours. Eric is saying, since the stuff is auto test, can we use that as a general guideline for how many marks we get for the exam? No. Yes, but no. Auto test will tell you whether certain things are working or not working in the program you have written. That's all I'm ever going to say about auto test. Auto test as a number of things that are correct or incorrect will not tell you how many marks you're going to get. They'll tell you roughly how many issues you have left in what you're doing, but not necessarily whatchamacallit, not necessarily how many issues are working or not. So you still need to be fitting the specification. Auto tests are there to give you reasons to change your code. So they'll show, oh, your code's not working for this example. And you go, okay, I need to change my code to work for that example. But that's going to open up an idea that that's not the only example that thing is triggering that my code is not working for. So you get the idea, right, of what I'm talking about? That the auto tests are there to remind you of what's working. They are not there for you to count up and to know how many marks you're going to get. So I've had people pass 3/4 of the auto test and get 0 for a question because the question was return a true-false answer. And so what they did was they returned true and they didn't write any code. They just returned true for all possible questions, all possible test inputs. And then we saw that they didn't get 100%, and so we looked at their code, and it was like, oh, the reason you didn't get 100% because your entire program was one line, return 1, and it was like, we can't give you any marks for that because you didn't show any understanding of the question, you didn't actually make a genuine attempt at it, right? So you can see there, the auto tests are not going to tell you all the time that your code is functioning exactly correctly. It might just be giving you information about, a little bit of information about what's working and what isn't. Yeah. Wendy, you went for a break and came back and we're still going. Yeah. Eric is wondering about when the exam marks are going to come back. I think we set a date for when they were going to come back, but I can't remember exactly when it was. I think it was about 2 weeks after the exam, or a little bit longer. It depends, because we have to mark the exam and the second assignment, and we've given some people extensions on the second assignment, which means the flow of how everything's going to happen will mean you'll probably get, like, I'd say 99% of the course, except for special consideration and other supplementary exam issues and stuff like that, are going to get their marks sometime, I think it was around the 7th of September. Oh, 2nd of September. So a little bit earlier than what I thought. Yeah. Edison is asking if there is a revision exercise. Oh, I think Chicken's trying to climb on my back. A revision exercise with a bunch of challenge lab exercises. No, we haven't. I think the main reason why we don't have stuff like that is that challenge exercises are much harder for us to write. Like, we have to think more to write them, so we don't have that many that are spares. You know, like, pretty much every interesting challenge is just in the labs already. I would love to write more of them because they're also, as much as they take more work, they're more fun for us to write. But again, as we've noticed, as Taylor noticed earlier, we have negative amount of time each term to run this course. If we had positive amount of time, as in we had more time than the course took to actually run, then we would probably write more of that stuff. But since the course actually takes longer to run than the amount of time we have to complete it, so it's always overlapping itself every time it runs, there's very little time for us to write more interesting stuff, which is why if you've looked at what we've released about, you know, if you look at previous iterations, like the term 2 like the term 1 iteration of the course, or the term 3 last year iteration of the course, and you look at the lecture slides and the tutorials and labs, because they're all publicly available. The answers aren't, but the questions are at least. You'll see a lot of the same stuff. You'll see that we can't change that much each term. Liang saying, in for question 7 is make a chess engine that can beat Stockfish 10. We're not going to make you make AI in 1511. We have done stuff like that before, but it was really simple. It was like just scripted stuff. Like if this, then this, then if this, then this. Yeah, and I think Tom's reiterating what I'm saying, that a question 6 in the exam is a lot of work. Like we can write questions 1 through to 4 really quickly. But a question 6 is usually something like, this is like Tom's saying this now, is the two of us will sit down. If we want to write a new question 6 or a new question 7, two of us will have to sit down for like a week and toss ideas back and forth and go, okay, let's compare this to previous exams. Is this the right level of difficulty? We write it, and then we have to rewrite it, because we have to say, is this actually readable? Is this understandable? Is this only understandable because we have advanced programming concepts? Like, given the tools that we've taught people, is this possible? You know, are they going to pick up the tricks that are necessary to make this work? Are we actually testing tricks or ability? You know, and so it's huge. And especially considering they're not worth that many marks for the overall for the course. There's only so much time we can spend on that. Having said that, there are other things that you can do. So coders, those of you who did like any coding competitions and stuff like that, can you send links now to the sample questions for those? Because some of those are going to be interesting. So I don't know if anyone did the, what do they call it, the Informatics Olympiad, which is a programming competition for high school students. I would say that some of the hard questions there are going to be similar to some of our hard questions, because when you think about it, someone in high school doing programming has probably about the same capability as someone who has finished COMP1511. I mean, you may have had more time to practice it, but you may not have had the same depth of learning that we have in COMP1511. So some of the hard questions can be a similar kind of thing. Yeah. But hard to say, you know. Is question 7 about the Riemann hypothesis? No, it will not be. Oh, as Tom's saying, you need to make an account for that one, so you'd have to set up an account, but I think it's free to set up an account. Yeah, it's also not, it's not always going to be the same, right? When we write a question for Comp 1511, it's really specific. Because if I want to examine you on something, it's examining you on something I've taught you, right? And that's very different from, this is just a generically hard programming question that might test you on things that I haven't taught, and it's not really worth it. That's actually the reason why Night Moves is in the tutorial. Because the fact that it's in the Tut lab means I've removed it from our exam, a possible rotation of questions in the exam. So it's what I consider a burnt question. The reason behind that is you can flick a switch for that question. The switch is you have not seen graph breadth first search before, which is a technical term. You'll hear about that later. Or you have seen a graph breadth first search before. If you have seen a graph breadth first search, it's easy. If you haven't, it's hard. And so that's nearly like the marks for that question are testing on background knowledge or not. So some people already are probably finding that question possible. If you're finding that question possible because you already know the technique for it, now you know why I had to take it out of the exam. Because some people get marks for that and other people don't get marks based on learning outside the course. And there's no point in examining people on learning outside the course. The marks you get for the course should be marks you earned in the course. So that's why Nice Move's a bit weird. Oh, Tom's got a blog post. Oh, that other site was broken, but he's got a blog post for questions from programming programming competitions and stuff like that. Okay, so I half promised this. I'll show you a bit of knight moves. So I'm not going to do it. There's too much of it to do. Oops, I have turned off some of my things, but I'll show you some of the theory that goes into the back end of something like knight moves. So we have a node, and the node has a position in it, and so we might use a struct for a position, and then from that position a knight can reach other positions. I'm not going to bother doing them all, but there's going to be at most 8 of them, because there's 8 different possible places a knight can move in one go. So this already is a little complicated, right? Because you've seen a linked list, which is a single string of things. Instead of that, I'm pointing out to multiple of these. However, if I want to, I can do this with a normal linked list, which is here, goes to a linked list. And we've seen this in assignment 2. Or here, I'm going to use a different color for a different possible solution, goes to an array. Because I know there's only 8 of these maximum. Yeah, 8. Because I only drew like 6 of them there. So I could have an array of 8 possible positions that I could reach from there. Each one of those could have a pointer to the position, or these could be pointers to positions. And for each of these, there's another 8. And for each of those, there's another 8. This is a concept known as exponential growth. So, let's take a really, really current example. Here is someone with the coronavirus. Here are the people they came in contact with. If each of them contracts the coronavirus, each of them then spreads it to 8 more people. If we do that, there are then 64 people, more than that actually, in the order of 64 people that have it. But what we're looking at here is the ability for us to say 1 step away from here is all of these, 2 steps away from here are all of these, 3 steps away from here are all of these. People are just like, yeah. So exponential growth is something that I think a great deal of the world's people who are complaining about just anything that they want to complain about, if they knew more about exponential growth, maybe would be a little bit more careful with themselves and their personal safety and other people's. Anyway, let's not get too deep into all that kind of stuff. Okay, so this idea will lead us to the possibility that we can say with certain number of steps into the future, what are all the possible positions that the knight could be in. So if we can look through all of these, and we think about it, it's just like there's 8 things here, and there's multiple data structures. This is just loops within loops. If we just do loops within loops, we can look at all of the positions the knight will be in and say, have we hit our target position? So we go, okay, here are all the positions we could be in 1 step. Have we hit the target position? If we haven't, we'll grow again. Have we hit the target position? If we have, we stop. If we haven't, we keep going. The concept is known as a breadth-first search because it's searching through this area of space of possible futures, but breadth is the width first, so it's searching all possibilities of a certain depth, and then all the possibilities in the next depth and things. So it's not easy. Takes a lot of thinking and fiddling to learn how to do this kind of thing, but that's how I would approach something like this. So I would have, so there's a lot of work here, right? The way that I would break down this problem is I'd have a knight simulator. So I would say, if I give the knight a position, the knight simulator will tell me all the positions it can move to in one step from there. That's one part of it. And that way I can use that thing to then have a future generator. The future generator says one step into the future, what are the new positions that are generated one step into the future? So this will be using that knight simulator to give us all the different positions, and the future generator would generate the data structure, either the array or the linked list, or however I'm going to do this. So you could do it a linked list or an array, or you could have 8 pointers in here to possible futures. If you want to get really, really like specific in a way that like humans could understand, you could be like northeast, northwest, and whatever, that kind of thing. Tom says I need a Mark mute button. Why are we muting me? I don't know what I was saying exactly 3 minutes ago. Whether I was giving something away or not. Anyway, so the funny thing about this exponential growth here is this is one of the things that makes this is like super. By the way, this is like what I did my research on. So this is like a whole lot of stuff I was doing in my PhD on playing games, where we look into the future. And in order to look into the future, we need to look at all the possibilities. So what we say is, every game that we play has a certain, what we call a branching factor, the number of possibilities that can happen in each step. Life has a massive, massive branching factor. So human life has like, I could decide to say this now, or I could not decide to say this now, and that's two different possible worlds we're in. But there's so many things that I could say right now. There's like billions of different things I could say right now in this instant. I chose to talk about night moves, but I could have talked about, I don't know, we could have gone back to League of Legends, or I could have talked about what I'm doing in Animal Crossing. I could stop and talk to Chicken, because Chicken's obviously, as you can hear, trying to talk to me right now. So many possibilities, right? And all you need to do is to go a couple of steps into the future, and every one of those possibilities is an exponent, as in power of something. So the power of 8, 1 to the power of 8 is not that big a deal. It's 1. Step 2, 2 to the power of 8. Wait. Oh no, this is 8. And then here, the next step is 2 to the power of 8. It's 8 to the power of 2. Sorry, I'm getting things mixed up. Yeah, but every time basically the exponent gets larger, the number of possible futures gets larger. And so that's why a lot of game playing algorithms become computationally impossible, because all you need to do is get a little bit further into this, and you've got a number big enough that it's around the number of atoms in the observable universe. Even really mundane things, like a deck of cards. So if you have a deck of cards, have I told you about this before? I've definitely spoken about this before. A deck of cards has 52 factorial different ways of being ordered. So every time you shuffle it, you have 52 cards in a particular order. If we multiply that out, so we see how many possible different orderings there are in a deck of cards, it's 52 factorial, which is 1 vigintillion. Is it 1? I think it's 80 vigintillion. It's a number big enough that I don't even know where vigintillion sits, because we know that like there's like millions, billions, trillions, quadrillions, etc. Vigintillion is somewhere there. As far as I remember, it's, I can't remember how many zeros, 70, 80 zeros after a 1. So it's big enough that, yeah, it's around the order of magnitude as the number of atoms in the observable universe, well beyond the computing capability of the entire human race all put together. I mean our computers, not our human brains, but it would be far surpassing our human brains as well. So you can't possibly check all futures of a deck of cards, so you can't even predict how a deck of cards will be dealt with 100% certainty. It's just not computationally possible, so you just have to make guesses instead. Night moves you can. Night moves is simple, because it only goes up by a multiple of 8 each time. And it stops spreading after a while, because there are, in all of these, there's a whole series of them that come back to these squares or these, and you can disregard them because you don't need to go in a loop and go back past yourself. So you can go back and you go, okay, search through the previous ones and don't go back to squares you've been to before, and that lowers this number from 8. Also, the closer you get to the edges, it lowers from 8 as well. So night moves grows but then sort of shrinks again. So that's why it's manageable computationally. Anyway, I am digressing. But this is one of the things I think that makes computing so interesting, is there's this idea of this kind of infinite possibilities in the future, and how can we model this so that we can gain an understanding from it and be able to, in some way, predict possibilities in the future so that we can choose between them. And that's exactly what we use computers for, where we think about what might happen, and we say the computer can deal with some of the alternatives that can happen, so that when this program runs, the program runs sometime in the future. We are predicting what kinds of inputs the program might have, and we're asking it to make its decisions based on those inputs. And we hope that the amount of intelligence that we can impart into the program is enough that it can deal with the situations it finds itself in. So, yeah, fun stuff like that. A little bit of theoretical computer science. Tom said 63 zeros, so the Vigintillion was 63 zeros. Liang's saying that doesn't that factor stop if you're waiting in line at a bus stop or something? But how many things can happen to you in a bus stop? You could meet, you could meet a friend that you hadn't seen in ages just because they happen to be in the area, and then you path off into a different world. You could get stung by a bee. You could get sneezed on and get coronavirus, because we're bringing back to the virus again. There's so many things still that could happen. Since there's this infinite possibilities, there's this infinite branching, which is why we've only been able to get the kind of future prediction that we'd like to have in really, really contrived specific systems like games, like turn-based games like chess and Go and things like that. And Go was only significant, whatchamacallit, we only had significant success. I say we because I'm a human. We robots only had significant success against humans in Go in the last 2-3 years. You know, I think when we played AlphaGo against Lisa Doll, that was 2016, I think, and before that, everyone had this idea that Go was so creative that a computer could never figure it out. There's this way of people playing Go where as you get better and better, everyone gets really similar. Everyone starts to play exactly the same way. And then at this Grandmaster level, it spreads again, and people's tactics and stuff spread really widely. But only if they're creative enough to be able to spread into those wide tactics can they genuinely win at a high-end competition level. And that weird spread of behavior made us think that AI would never really pick it up, because there was this spark of human creativity. Well, we were wrong. AI is the best Go player on this planet. So I'm giving away the thing. There's a documentary called AlphaGo. It's on Netflix. You should totally watch it. It's a beautiful documentary about artificial intelligence and the interaction between artificial intelligence and humans and things. And I think it's super, super interesting. Especially because I don't know for certain, but I think some of the research that I was doing influenced some of the people who worked in the company that did that. Maybe, if I'm lucky. Because I know that there were definitely people who I saw in the background who I'd met at conferences and stuff like that. And I've got friends that work for Google DeepMind now as well. So maybe there's a tiny bit where I helped. Yeah. Okay. So I've digressed very far into wildness, but at a really, really basic level, Knight's Moves is considered a trivial example of that field. But obviously, you don't get deep into that field without several years of training. So you've had 0 years of training in that field. Well, not entirely 0, some small fraction. So getting to this idea is something that's theoretically possible using the techniques you have. but to be able to pull that off in an exam, it's very difficult. Liang's asking if I worked on AlphaGo. I did not work on AlphaGo, but I did research and I published it with some people who did work on AlphaGo. I don't know how much my research affected what they did, but I definitely know that they read one paper that I wrote that would have been very, very useful for the approach that they took on AlphaGo. So there's something in that maybe I've helped push something along a millimeter further than it would have been otherwise. I'm probably just taking credit for something that has no relevance at all, that didn't exist, but who knows. Okay, I'm going to wrap it up there because I think we've reached a point where no one's asking any programming questions anymore. Wendy said, do you think you've achieved the best possibility of your life in the grand scheme? And if there was a fortune-telling machine, would you use it? Wendy, I do not think that I have achieved the best possibility for my life, but I think if I had, I would have trouble measuring what best is. So am I the happiest? Have I achieved the things that are the greatest potential for benefit to mankind? And I like the word mankind. Have I achieved things that are going to help our societies grow and become better? I don't know. Do I have a limitation as a human being? I'm sure I do. I don't know exactly what it is. So I think I have been reasonably happy with what I'm doing, and I think that I've been reasonably successful in helping students achieve things that they want to achieve, which is better, I think, than helping students achieve what I want them to achieve. But I don't know. I think it's going okay. It's going well enough that I'm not needing to change things right now. The world is a messed up place, though. And so if I was going to be in the best possible possibility, I would want the rest of the world to be better. Yeah. If there was a fortune-telling machine, would I use it? 100%. I use one every day when I'm checking the weather. That's all fortune is. When we're looking at things, we're looking at predictions at different levels of accuracy based on data that we can see right now. So, if we could map out the movement of every single atom as it is moving right now, we'd have a reasonable idea about what's going to happen next. By the time we'd calculated at that level what was happening next had probably already happened, so it's not that useful, but we can see that. And so when we think about predicting the weather, that's a fortune-telling machine. That's saying that in the next 48 hours there's a reasonable idea of atmospheric movements. And that's what genuine fortune-telling is going to be. As our computers get better, we're going to be able to sample more data, and we're going to be able to say, this is what's likely to happen. Okay, let's not continue that much. Oh, Wendy, that's very nice of you. She said, I've changed many lives, so definitely helped mankind. Okay. I hope that I've helped a lot of students. Edison said, am I going to be at the revision session tomorrow? Yes. I will pick and choose the times that I'm at the revision session and my level of involvement, but you will most likely see me in the early afternoon and the dead of the night, because those are the times where I do the most work. Okay, I'm going to leave it there, because we've now gone for 3 hours when I said we were going to go for 2. I have to check what's happening on my island in Animal Crossing. My Animal Crossing island is called Chicken. So it's Chicken Island. So it's actually her island. So Chicken's going to say goodbye now. Oh. You okay, Chicken? Okay. So I'll wrap it up there. If anyone's going to the study session tomorrow, I'll see you there for a little bit here and there. Maybe I will see some of you during the exam. I mean, usually I'm only going to talk to you during the exam if you have issues and you need to email us about it. Um, but yeah, thank you all for coming along. Lots of people saying thank you in the chat, so you're welcome. I hope that there was at least a little bit of help. We did a bit of coding. We did a lot of just sort of chatting. This is obviously not the last time you're going to see me. I will be doing more things that are just sort of chill out things. So we'll probably have some kind of chill out stream during the holidays, and I'll see if I can get Hannah along to interview her. But I also might do some other interesting things because I think students probably want to hear from industry professionals and stuff like that. And realizing that my list of contacts amongst industry is kind of huge because they're just all the people I studied with who are now in charge of different things. So I've got some friends who I could bring along and just kind of interview them, or even just let you ask questions of them. They can talk about it, and then we can do stuff like that. I will probably talk to CSC SOC and women in tech about this kind of stuff rather than just going rogue and doing it all myself. Because I think it's much better if this stuff is done in the student societies rather than me just going, oh, I'm just going to do a random thing. But random hangouts that don't have any kind of specific events or guests and stuff like that, we might just do for fun. Shrey wants me to do vlogs and a podcast. I mean, that's a possibility. I could do something like that. But thank you, everyone, and thank you especially for thanking the tutors. The tutors do a hell of a lot of work in this course. A lot of them are putting in, you know, similar kind of hours than I am, like full-time hours, because they're getting caught up in a lot of the detail in what's going on for the course, and so we should definitely thank them. Send an email to your tutor thanking them. It'd be nice. They also have a My Experience survey, so you'll have a survey for the course, a survey for me, and a survey for each of your tutors. So there might be several surveys. Please fill them out. It's really handy for the tutors to know because some of the tutors are still learning how to teach in a sense, and so for them it's very, very good to get your feedback, and they can see what they're doing that's working and is not working, and they can also feed that back to me. We can make the course better. So when we're thinking about the effect we have on other people's lives, as we were talking about before, you can have an effect on making my effect on other people's lives better. So if you can help improve COMP1511, it gets better for future generations of computing students, and that's a really nice feeling to be, even in your first year already, giving back to computing and making it better. Okay, I'm going to wrap it up there. Thank you very much, everyone, and I'll see some of you tomorrow, and otherwise I'll see all of you later whenever I organize another thing that's happening. All right, goodbye all.